Welcome to GATE 2022 Solutions of Electronics Engineering. Dear friends, GATE is over and now what is your performance? You must be interested to know your marks, your rank and your performance. So whatever we have today is memory based questions. Students have shared their questions and based on the memory जितने भी questions हमको receive हुए हैं, so our faculty members will discuss their probable answers, closest answers. But yes, we know that after a week exact paper will be available, complete paper will be available, and then we will be able to provide the complete solutions of all questions. Today also most of the questions are available and we will discuss. Few things I want to share before the discussion starts. The first thing is that many of you have written the GATE this year. You may not be able to get the good rank or good score and you may be planning for the next year. So 2023 GATE again you will write. So I want to suggest you don't stop. Continue the journey. Success is all about the consistent efforts. And if you are willing to take any guidance and support next year from the GATE for the next year 2023 GATE, then GATE is going to conduct the National Scholarship Test. This National Scholarship Test will be conducted on 22nd and 27th of the February and last date to apply is 19th February. तो दोस्तों अगर आपको लगता है कि स्कॉलरशिप चाहिए, आपको तैयारी करनी है, तो एक बहुत ही अच्छा मौका है, आप स्कॉलरशिप के लिए अप्लाई कर सकते हैं. ऑनलाइन बैचेस जिसको ज्वाइन करना है, लाइव ऑनलाइन क्लासेस, for them NST1 will be conducted on 22nd of February and last date to apply is 19th February. और जिसको ऑफलाइन क्लासेस करनी है, they can attend or appear in the second NST and that is on 27th of the February. इसके अलावा दोस्तों अभी गेट का जैसे ही मार्क्स आ जाएंगे एंड क्वेश्चन पेपर आ जाएगा, क्वेश्चन पेपर आने के बाद we will give you the probable rank by the rank predictor. GATE rank predictor will be active from this week. So that also will help you to gauge your performance. In addition to that, engineering services exam is scheduled next Sunday, means next to next Sunday, which is on 20th of February. So we will come out with the live solutions of the ESE 2020 prelims exam. After the engineering services, what you gauge yourself and after the GATE result, how you find your performance and then plan your journey for the next year. और कहीं भी किसी तरह की भी कोई सपोर्ट सिस्टम अगर चाहिए, then GATE will definitely help you. If you are the GATE student or you have been the GATE student in the past, कभी भी तो आप किसी भी तरह का आपको सपोर्ट चाहिए, we are very eager to help and support you. किसी भी तरह की कोई भी प्रॉब्लम है, you just bring in our notice, we will definitely help you. जो ऑनलाइन कोर्स की वैलिडिटी है, the live ऑनलाइन कोर्स के वीडियोज, the validity was till the GATE exam and now we have already notified the validity will be extended till 31st of March for the 2022 batches. तो इस 1.5 month में आप अपनी रिमेनिंग एरियाज या सिलेबस कंप्लीट कर सकते हैं. 31st मार्च के बाद भी अगर किसी को जरूरत होगी ऑन द नॉमिनल पेमेंट बेसिस एक्सटेंशन प्रोविजन विल बी मेड. जो स्टूडेंट क्लासरूम के हैं और जो पहले यहाँ क्लासरूम कोर्स में रह चुके हैं, इफ यू हैव लेफ्ट एनी एरिया एंड यू फील दैट कि सर्टेन एरिया यू वाज नॉट एबल टू अटेंड और नॉट एबल टू डू बिकॉज ऑफ द ऑफलाइन एंड ऑनलाइन transition, COVID has been a tough situation for everyone, you and we all suffered. तो अगर आपको ऐसा लगता है कि you want to attend again in offline, then you can come for those subjects which you have not been able to do. और जिस तरह से हम लोगों ने कमिटमेंट किया था, we have provided the best possible solutions and supports and we are committed to give. आप लोगों ने over the period of time एक चीज फील की होगी कि GATE is different from the other institutions in many respect, whether it is the support to the students or it is the quality of teaching or quality of content. You have seen that कि we don't waste even a single hour in the classes or a single minute in the class. Every subject starts and finishes with time and in sequence. All the teachers are experienced and they have the knowledge of their field, and most important is that we value for your time. So that is something which is different in the GATE. ऑफलाइन हो या ऑनलाइन हो, दोनों जगह हम लोगों ने जस्टिफाई करने की कोशिश की है एंड वी हैव गिवन आवर बेस्ट पॉसिबल एफर्ट्स. एफर्ट्स आर स्टिल रिक्वायर्ड, वी कैन फर्दर इंप्रूव एंड विल कीप ऑन सपोर्टिंग इन ए बेटर वे. सो डियर फ्रेंड्स, द जर्नी इज बिगिनिंग and your journey of GATE was last today, but again the next journey starts today. You should not stop unless you get the final call letter in your hand. One more thing you should remember, GATE is not the final destination. Job is the final destination. Even after doing MTech, you want to go for a job. So selection is important and a final selection is important. So do not get demoralized or disappointed if your performance is not good. Continue, and whatever you have studied and prepared, this becomes the basis for the future, and in the time coming ahead you will be able to crack so many other exams. So keep on writing the other exams. एक तो सबसे बड़ी बात यह है कि बहुत सारे स्टूडेंट्स सोचते हैं कि अब तो साल बर्बाद हो गए, गेट अच्छा नहीं हुआ, अब क्या होगा, बट डियर फ्रेंड्स, this is part of the life. It happens. When there is day, there will be night. When there is night, the day is bound to come. So if you have not been able to perform, you will be able to perform in the time coming ahead if you continue your consistent efforts. So keep on doing your work and efforts, and let us wait for the right time for the success. So I will now introduce the faculty members. They will start the discussion of the subject. According to the opinion of his students, it has been observed that the question paper is not that tough. In fact, we can say it is a moderate, but tough and moderate or easy depends on your preparation. For many, this paper may be difficult. For many, this paper may be moderate or easy. So it all depends on your performance. One thing we have noticed that the number of the multiple select questions have increased this time, and when MSQ are more, score becomes difficult. So getting easy score is not the case. So those of you who have not made any mistake, they will be able to get the good marks. So the first subject will start with EDC, and in EDC Mr. Sunil Tiwari and Mr. Kamesh Srivastava will start the discussion, and one by one subject we will take up, and all the concerned faculty members who are the expert of their areas, they will discuss. That is the unique thing in BATG. One teacher is not teaching all these subjects. In fact, in every subject there are these specific and specialized teachers. They take the classes, and that is how this institution is different from the other places. And one more thing which I want to suggest you finally, even you don't perform well in this GATE 2022, you should not be disappointed. If any support you want, think of BATG, think of BSync. We will help you, and we will definitely provide best possible support. So over to Mr. Tiwari and Mr. Kamesh.
Thank you, sir. Good evening, friends. In EDC, we got 3 questions, and these are the memory based questions. So whatever data you all have provided, we are proceeding according to that data only. And we didn't get much questions in EDC, only 3 questions we get. So if you get more questions, you can send it to the MEDIGI Telegram channel or any other platform of the MEDIGI, and we will provide solutions later on also if the questions are available. Right now we are starting with the first question, and the first question is related with semiconductor physics. Very simple question, and we have done such kind of questions on various courses in various platforms, like in GTQ we discussed, in concept series we discussed questions related with Fermi energy level. So let us see, for a non-degenerate semiconductor with electron concentration 10 to the power 16 per centimeter cube, the difference between the bottom of the conduction band and Fermi level of electrons is this much. Assume the thermal voltage VT is 26 milli electron volt and intrinsic carrier concentration of semiconductor is 10 to the power 10 per centimeter cube. If the electron concentration becomes 0.5 into, you see the electron concentration is just half of the previous value, then he is asking what is the difference between the bottom of conduction band and Fermi level of the electrons. So very simple question. We all know what is the relationship for n-type semiconductor. We have a standard relation, n is equal to nc e to the power minus ec minus ef upon kt, right? This is the electron concentration, where nc is effective density of states in conduction band, and this depends upon temperature as well as the effective mass of electrons in conduction band. So he is mentioning nothing about these 2 parameters, and even he is telling you about the thermal voltage, that is 26 millivolt. It means at the room temperature we have to do all calculations, so we can assume that NC is constant. He is not going to vary this thing. So अगर NC constant है, यहाँ से आप EC minus EF निकाल लीजिए. EC minus EF is equal to KT ln, and this is NC divided by N, right? In first he is saying that this is, let us suppose we are putting different values of n. So if we are putting the first value of n, I am assuming it EC minus EF 1 and this whole 1, this is equal to KT ln and nc upon n1, equation number 1. Similarly, if we change the electron concentration and we are keeping all other parameters constant, so if we change electron concentration, then this will change. So in the second case, EC minus EF2 Fermi energy level will change according to the electron concentration. Then this is KT ln, NC will remain same, क्योंकि ना ही हम इफेक्टिव मास ऑफ इलेक्ट्रॉन चेंज कर रहे हैं और ना ही टेम्परेचर चेंज कर रहे हैं. तो अगर ये दोनों चीजें चेंज नहीं कर रहे हैं तो NC पर कोई चेंज नहीं आएगा, तो NC कांस्टेंट रहेगा, लेकिन इलेक्ट्रॉन कंसंट्रेशन हमने चेंज कर दी है. नाउ दिस वैल्यू वी आर वांटिंग टू कैलकुलेट. तो अब इसमें क्या करें, हम इक्वेशन 1 से इक्वेशन 2 को अगर सब्ट्रैक्ट कर दें तो हमें आंसर मिल जाएगा. सो लेट अस सब्ट्रैक्ट इक्वेशन 1 माइनस इक्वेशन 2, ऐसा मैं कर दे रहा हूं. तो EC माइनस EF1 1 माइनस EC माइनस EF2 एंड दिस इज इक्वल टू KT ln NC अपॉन N1 माइनस KT ln NC अपॉन N2. ये क्या बन जाएगा, KT कॉमन ले लीजिए, log x माइनस log y, दैट इज log x बाई y. सो log x बाई y आप ऐसे लिख सकते हैं, दिस इज KT ln, ये x है, दैट इज NC अपॉन N1 राइट, बाई y, तो ये हो जाएगा NC अपॉन N2. इस तरह से लिख सकते हैं. ठीक, इसको थोड़ा सा सिंप्लीफाई कर लीजिए, KT ln, NC NC कैंसिल हो जाएगा और ये आ जाएगा N2 अपॉन N1 right, and this value is given to us. This is EC minus EF1 in the first case minus EC minus EF2 for electron concentration 2 right. Now we have to calculate this value. हम लोग इसको इधर लेके चले जाएं और या यहीं पर वैल्यूज पुट कर सकते हैं. आप ये वैल्यूज पुट कर दीजिए और सॉल्व कर लीजिए. So if we put these values, this value is given to us 200 milli electron volt, 200 milli electron volt minus EC minus EF2 is equal to KT is given to us, that is 26 milli electron volt at room temperature. So 26 milli electron volt multiplied by ln. This value is also given 0.5 into 10 to the power 16 divided by 0.5 into 10 to the power 16 right. ये कैंसिल हो जाएगा, सॉरी ये 1 है, दिस वैल्यू इज गिवन एज 1, N1 is 1 right. So this comes out as 26 milli electron volt ln 0.5. This is roughly around minus 18 milli electron volt, minus 18 milli electron volt, and this is 200 milli electron volt minus EC minus EF2 2. ठीक, इसको इधर ले जाइए, इसको इधर लाएंगे, ये प्लस में हो जाएगा, ये भी उधर जाकर के प्लस में हो जाएगा. सो EC माइनस EF2 2, दैट इज 200 प्लस 18, दैट इज अप्रॉक्सीमेटली 218 मिली इलेक्ट्रॉन वोल्ट. सो बहुत ही सिंपल क्वेश्चन था, आप सभी ने इस क्वेश्चन को कर लिया होगा कंसेप्ट ऑफ फर्मी एनर्जी लेवल से. इसमें सिर्फ एक फार्मूला आपको जो ध्यान रखने की जरूरत, मैं जैसे हमेशा आपसे कहता रहता हूं कि एन और पी कंसंट्रेशन को आप डिफरेंट फॉर्मेट में याद रखिए तो आपसे क्वेश्चन बन जाएगा. ठीक, नेक्स्ट क्वेश्चन आपसे कामेश सर डिस्कस करेंगे, उसके बाद फिर मैं आगे फिर से दोबारा आपके साथ डिस्कस करूंगा. लीजिए सर.
Okay, so this question based on the MOS capacitor. So if you remember, this type of question is there in the MEDISI workbook, and this type of simple question sir also discussed in the class and I have also discussed in the classroom. And one important thing about this question is very similar question is available in the previous year GATE, where the threshold voltage was given in that case and COX was not given. In this case COX is given and VT is not given. Now see what is the interesting point in this question. So an ideal MOS capacitor where p-type semiconductor is there, substrate is p-type, and this MOS capacitor is under strong inversion condition. The value of inversion charge density in coulomb per centimeter square, micro coulomb per centimeter square at Vg equal to 2 volt is given. Now assume oxide capacitance per unit area COX equal to 1.7 microfarad per centimeter square, COX is given. Okay, Now for Vg equal to 4 volt, different value of Vg, we have to calculate inversion charge density Q inversion. Very simple question, and you can find this formula in my notes at short channel MOSFET topic, where I discuss the current of nanoscale MOSFET. Okay, so now we can solve this simple questions by using the simple equation of inversion charge. Okay, so if we talk about the inversion charge, so you know very well the formula for inversion charge is inversion charge. You know very well, when we increase the gate voltage, inversion charge increases. Meaning is that Q equal to CB formula is there. Okay, so basic formula equal to Q equal to CB. But you know very well, when gate voltage is greater than threshold voltage, then only we will get the strong inversion condition. So by this, inversion charge density formula is oxide capacitance COX into Vg minus Vt. Meaning is that how much Vg is greater than Vt, it decide how much inversion charge is there. Now, so what we have to do is, in this question, COX is given. First we will calculate the Vt by using first data. Okay, so what is the formula for Vt? Qin upon COX will be equal to Vg minus Vt. Now what is the answer for Vt is, Vt is equal to Vg minus inversion charge density upon COX. Now what is the first data? First data is for Vg equal to 2 volt, at Vg equal to 2 volt, inversion charge is given 2.2 microcoulomb per centimeter square, and oxide capacitance is given 1.7 microfarad per centimeter square. Remember, all the units are in the centimeter, both are in the micro, that will be cancel out. If we calculate this value, you will get some Vt is equal to 0.706 volt. Now you are having Vt value, you can calculate inversion charge at different value of VGS. Okay, so now what is the inversion charge? Qin at Vg equal to 4 volt, that we have to calculate. If you calculate this, okay, so if you want to calculate inversion charge at Vg equal to 4 volt, you can apply the same formula. Qin is equal to COX gate voltage Vg minus Vt. Now what is COX? COX is given 1.7. okay, so that is 1.7 microfarad per centimeter square, and the gate voltage is 4 volt, at which we have to calculate this inversion charge density, and the threshold voltage we have calculated, that is 0.706 volt. So now you will get inversion charge in microcoulomb per centimeter square, and this answer is 5.5998 microcoulomb per centimeter square. So this is the answer for the inversion charge density. This is a very simple question, and the next question based on the semiconductor sir will discuss. Okay,
this kind of questions are very repeated in GATE. This is related from continuity equation topic. Basically you see p type semiconductor having hole concentration P. So basically अभी जो हम लोगों को डेटा मिला, हम श्योर नहीं है कि ये आपको टोटल कंसंट्रेशन दे रहा है या थर्मल इक्विलिब्रियम पर. हम ये एज्यूम कर रहे हैं कि जो ये कंसंट्रेशन मिली हुई है वो थर्मल इक्विलिब्रियम पर कंसंट्रेशन दी हुई है और उसके अकॉर्डिंग सॉल्व कर रहे हैं. अगर आप डेटा अप्रोप्रिएट जब आगे मिल जाएगा तो उसके अकॉर्डिंग दोबारा सॉल्यूशन डिस्कस कर लिया जाएगा. तो अभी जितना डेटा है उसके अकॉर्डिंग सॉल्व करने की कोशिश कर रहे हैं. सो मैं ये मान रहा हूं कि ये जो हमें दिया हुआ है थर्मल इक्विलिब्रियम पर होल कंसंट्रेशन, जिसका मतलब एक्सेप्टर कंसंट्रेशन के इक्वली वैल्यू दी हुई है, एंड इंट्रिंसिक कैरियर कंसंट्रेशन दिया हुआ है. इट इज इल्यूमिनेटेड बाय लेजर एट द लेफ्ट एंड ऑफ द सेमीकंडक्टर एट x इक्वल टू 0. गिवन डिफ्यूजन लेंथ ऑफ द इलेक्ट्रॉन एंड होल्स आर दिस. सो ln given diffusion length of electron and holes. So basically ये ln दिया हुआ है और ये हमें lp दिया हुआ है respectively, and electron density x is equal to 0 पर this much दी हुई है due to illumination. वो कह रहा है due to illumination electron density है, इसका मतलब it is excess carrier concentration due to shining light at x is equal to 0. That value is given to us. अब हमें 2 माइक्रोमीटर पर ये वैल्यू बताना है. ये बड़ा पॉपुलर क्वेश्चन है. सेम टाइप ऑफ क्वेश्चन हम लोग वर्कबुक में भी करते हैं, टेस्ट सीरीज में भी ये क्वेश्चन था. इसको कर लेते हैं. सो सबसे पहले ये देखिए, ये पी टाइप सेमीकंडक्टर है. तो पी टाइप सेमीकंडक्टर में ये मैं मान लेता हूं कि ये x इज इक्वल टू 0 पॉइंट है और ये हमारा x एक्सिस है. तो अगर हम लोग इस एंड पर लाइट साइन कर रहे हैं तो एक्सेस कैरियर्स यहां पर डेवलप होंगे, लेकिन फॉर x ग्रेटर देन 0 हमारे पास कोई लाइट नहीं है. जो लाइट है वो कहां पर है? x इज इक्वल टू 0 पर. हमें जो कैरियर कंसंट्रेशन कैलकुलेट करना है वो x ग्रेटर देन 0 के लिए कैलकुलेट करना है, ये ध्यान रखिएगा। तो x इज इक्वल टू ग्रेटर देन 0 पर जनरेशन रेट 0 हो जाएगी। जनरेशन कहां हो रहा है? सिर्फ x इज इक्वल टू 0 पर हो रहा है। अब मैंने आपको बताया कि अगर ये p टाइप सेमीकंडक्टर है तो कंटिन्यूटी इक्वेशन किसके लिए लिखेंगे आप? माइनॉरिटी कैरियर्स के लिए। p टाइप में माइनॉरिटी कैरियर्स क्या होंगे? इलेक्ट्रॉन्स होंगे। तो इलेक्ट्रॉन के लिए अगर हम लोग कंटिन्यूटी इक्वेशन लिखते हैं तो क्या आएगा? कंटिन्यूटी इक्वेशन फॉर द इलेक्ट्रॉन। इस तरह के बहुत क्वेश्चन मैंने आपको कराए हुए हैं, टेस्ट सीरीज में भी क्वेश्चन है, सब जगह है, वर्कबुक में भी किए हुए हैं हम लोगों ने। कंटिन्यूटी इक्वेशन फॉर इलेक्ट्रॉन्स, इलेक्ट्रॉन्स के लिए कंटिन्यूटी इक्वेशन लिखिए। ठीक, देखिए ये क्या होगा? dn अपॉन dt इज इक्वल टू n म्यू n e n म्यू n d अपॉन dx, ठीक है, प्लस म्यू n e dn अपॉन dx प्लस gn माइनस rn प्लस dn d2n अपॉन dx2। ठीक है, अब एक चीज देखिए, यहां पर इलेक्ट्रिक फील्ड के बारे में कुछ भी नहीं मेंशन है। हम लोग क्या करके लेकर के चलेंगे? इलेक्ट्रिक फील्ड को 0। सो दिस पोर्शन एंड दिस पोर्शन विल बिकम 0। फॉर x ग्रेटर देन 0 लाइट क्या है? 0, कोई लाइट नहीं है हमारे पास। ठीक, उसके बाद यहां पर देखिए n जो होगा, दिस n इज इक्वल टू n नॉट प्लस डेल्टा n। अब सबसे पहले थर्मल इक्विलिब्रियम पर आप n नॉट निकालने की कोशिश करिए। उसके लिए हमें इंफॉर्मेशन दी हुई है, ni दिया हुआ है और एक्सेप्टर कंसंट्रेशन या होल कंसंट्रेशन दी हुई है। तो थर्मल इक्विलिब्रियम पर अगर माइनॉरिटी कैरियर कंसंट्रेशन निकालते हैं तो n नॉट इज इक्वल टू ni स्क्वायर डिवाइडेड बाई na। ठीक, ni स्क्वायर इज हाउ मच? 10 टू द पावर 10 का स्क्वायर, दैट इज 10 टू द पावर 20 डिवाइडेड बाई na। na कितना दिया हुआ है? दैट इज 10 टू द पावर 17। सो ये हो जाएगा 10 टू द पावर 17, ये आएगा रफली 10 टू द पावर 3। आप एक चीज देखिए, यहां पर जो x इज इक्वल टू 0 पर हमें डेटा दिया हुआ है वो कितना दिया हुआ है? 10 टू द पावर 14। इसका मतलब एक्सेस कैरियर कंसंट्रेशन इज वेरी हाई एज कंपेरिजन टू द थर्मल इक्विलिब्रियम कंसंट्रेशन। यहीं पर आप अप्रोक्सीमेशन कर सकते हो कि n इज अप्रोक्सीमेटली इक्वल टू डेल n, बिकॉज दिस वैल्यू इज इन द रेंज ऑफ 10 to the power 3 and this value at x is equal to 0 is in the range of 10 to the power 14. So this value is very high as comparison to this value, so we can get a approximation that is n is approximately equal to del n. अब n is equal to approximately equal to del n, उससे पहले एक और चीज, हमें स्टेडी स्टेट में सारा कैलकुलेशन करना है। तो स्टेडी स्टेट में कैरियर कंसंट्रेशन टाइम के रेस्पेक्ट में क्या होती है? कांस्टेंट होती है। तो जब डिफरेंशिएशन करेंगे तो ये वैल्यू क्या हो जाएगी? 0। अब इस इक्वेशन को हम इन सारे डेटा के हिसाब से जो मॉडिफाई कर सकते हैं वो 0, ये सारा टर्म 0 हो जाएगा एंड दिस टर्म dn, ठीक, n की जगह पर हम लोग क्या पुट कर दें? d2 del n अपॉन dx2 माइनस rn क्या हो जाएगा? del n अपॉन टाउ n। ठीक, ये बहुत ही पॉपुलर इक्वेशन है आपकी, del 2n अपॉन dx2 इज इक्वल टू del n अपॉन ln स्क्वायर, वेयर ln इज इक्वल टू अंडर रूट dn इंटू टाउ n। ये सब आप लोगों को कराया गया। ये सेकंड ऑर्डर डिफरेंशियल इक्वेशन है, 2 कांस्टेंट होंगे, मैं पूरा सॉल्व नहीं कर रहा हूं। इसका डायरेक्ट इक्वेशन जो सॉल्यूशन हम लोग लिख देंगे वो क्या होगा? डेल n एज अ फंक्शन, ये किसका है? x का फंक्शन है, तभी डिफरेंशिएट कर रहे हैं। नाउ डेल n एट 0 e टू द पावर माइनस x बाई ln। ठीक, ये इंफॉर्मेशन हमारे पास अवेलेबल है। x इज इक्वल टू 0 पर कितनी वैल्यू दी हुई है एक्सेस कैरियर कंसंट्रेशन की? 10 टू द पावर 14। सो लेट अस पुट दिस वैल्यू 10 टू द पावर 14 e टू द पावर माइनस x बाई, यहां देखें ln की वैल्यू कितना दी हुई? ln इज डिफ्यूजन लेंथ फॉर द इलेक्ट्रॉन्स। हमें दोनों की डिफ्यूजन लेंथ पता है, इलेक्ट्रॉन के लिए भी, होल के लिए भी। लेकिन p टाइप में हमें माइनॉरिटी कैरियर क्या है? इलेक्ट्रॉन। सो वी आर इंटरेस्टेड इन इलेक्ट्रॉन। सो इलेक्ट्रॉन की डिफ्यूजन लेंथ कितनी हो जाएगी? 2 माइक्रोमीटर। ये वैल्यू पुट कर देते हैं, इलेक्ट्रॉन की डिफ्यूजन लेंथ 2 माइक्रोमीटर हो गई। ठीक है, अब यहां से x इज इक्वल टू 2 पर हमें कैलकुलेट करना है। सो डेल n x इज इक्वल टू 2 माइक्रोमीटर, इसको पुट कर दीजिए 10 टू द पावर 14 e टू द पावर 2 बाई 2 कैंसिल होकर के -1। अगर आप याद करो तो सेम डेटा के साथ भी किसी एक जगह पर हम लोगों ने ये क्वेश्चन किया है, e टू द पावर -1 से याद आएगा, शायद टेस्ट सीरीज में या कहीं सेम डेटा के साथ ये क्वेश्चन हुआ। इसको सॉल्व कर लेंगे, कितना आएगा? इसको सॉल्व करने के बाद कैलकुलेट करें, इसको सॉल्व करने के बाद 3.67 3.67 इंटू 10⁻13 पर सेंटीमीटर क्यूब, ये आंसर आएगा। अब यहां एक कंफ्यूजन हो सकता है लेस अवेलेबिलिटी ऑफ डेटा की वजह से कि टोटल कंसंट्रेशन पूछा था या एक्सेस कैरियर पूछा था, लेकिन दोनों ही केस में आपका आंसर सेम रहेगा। अगर आपसे टोटल कंसंट्रेशन भी पूछा होगा तो वो कितना होगा, एन नॉट प्लस ये जो डेल एन आपने कैलकुलेट किया, लेकिन एन नॉट कितना है 10⁻13, आप सॉरी 3 10⁻3। सो अगर आप 10⁻3 ऐड भी कर रहे हो तो भी कोई चेंज नहीं आने वाला है। सो चाहे उसने टोटल कंसंट्रेशन पूछा होगा या एक्सेस कैरियर कंसंट्रेशन पूछा होगा, दोनों ही केस में सेम आंसर आपको मिलने वाला है। इस तरह के बहुत सारे क्वेश्चन आपने पहले से किए हुए हैं। अगर आपको और भी किसी क्वेश्चन का आंसर चाहिए, हमें अभी यही 3 क्वेश्चन मिल पाए हैं, हो सकता है आप में से बहुत सारे लोग इंस्ट्रूमेंटेशन का पेपर दे रहे हो तो बिजी हो, तो अगर आपको किसी भी अन्य क्वेश्चन का सॉल्यूशन चाहिए तो आप मेडिजी के टेलीग्राम चैनल पर भेजिए, वहां से हम लोग उसका आंसर लेकर के और आपके साथ मिलेंगे। ठीक है, कामेश सर कुछ कहना चाहेंगे?
Yes. And dear friends, remember these question solutions are based on the data provided by the students. So in this question, some students are saying that diffusion length of electron and holes are given by the by changing 1 micrometer and 2 micrometer respectively, then answer will change. Okay, so we have done the procedure and that is the correct answer that is given by the sir. Okay, and if you get some questions, definitely share with us or Medici group, then we will solve those questions. Okay, thank you, and respective faculty will take the next subject definitely.
और अगर आपका पेपर खराब भी गया है, किसी भी कारण से आपका पेपर अगर खराब हुआ हो, तो मैं एक चीज कहना चाहूंगा कि ये एंड नहीं है, आखिरी एग्जाम नहीं है। अभी 10 दिन बाद आपको इंजीनियरिंग सर्विसेज का भी एग्जाम देना है, 10-15 दिन बाद। इसको भूल करके और इंजीनियरिंग सर्विसेज के लिए लग जाइए और अपनी प्रिपरेशन करिए। किसी भी तरह की जरूरत पड़ रही है तो हम लोगों को कॉन्टैक्ट करिए। वी आर ऑलवेज रेडी टू हेल्प यू इन बेस्ट पॉसिबल मैनर। जिस भी तरह से हम लोग कर सकते हैं, हम लोग आपकी हेल्प करने की कोशिश करेंगे। नेक्स्ट सब्जेक्ट आपकी कंट्रोल सिस्टम होगी, अगले सर आकर के कंट्रोल सिस्टम पर डिस्कशन करेंगे। थैंक यू।
Hello everyone, let's take up control system questions now. Altogether 5 questions came, near about in weightage of 8 to 9 marks. That's good enough as an usual weightage for the control systems in electronics and communication. Let me take those questions one by one. A question here regarding the Nyquist plot is given. The Nyquist plot of a system, an open loop transfer function for k is equals to 1 is shown. For k is equals to 2, then how many number of closed loop poles will be in the right side of S plane? And it is known that the open loop transfer function has no pole in the right side of S plane. This diagram is given for, as mentioned, for value of k is equal to 1. Actually k is open loop gain, and each magnitude it has to be multiplied with a value k. So this is like 0.4k and this is like 0.8k. Since k is equal to 1, it is 0.8 and this is 0.4. If k is equal to 2, this becomes 1.6 and this becomes 0.8, of course on minus 180 axis, so minus 1 comma 0 lies here because this is minus 0.8 and this is minus 1.6. Now minus 1 comma 0 is encircled by this Nyquist plot 2 times in clockwise direction, once here and once this. So n is minus 2. By default, Nyquist contour is considered to be in clockwise direction. So encirclements of the Nyquist plot with respect to minus 1 comma 0 in clockwise will be negative and anti-clockwise will be positive. So n is minus 2 and it is mentioned that there are no open loop poles in the right side of S plane. P is equal to 0. The number of closed loop poles lying in the right side of S plane P minus n happens to be 2. So answer to the question is two closed loop poles are in the right side of S plane. Moving to the next question. Question is, characteristic equation of a system is given. The question is to find the value of k for all the roots to be lying on the imaginary axis. See, they may be simple imaginary or multiple imaginary. There are 4 roots. All 4, they have to be on j omega axis. They may be like this, that is simple imaginary, or it may be like this, that they are multiple imaginary. It means that 4 roots are symmetrically located with respect to origin. 4 roots are located symmetrically with respect to origin. In that case, S cube rho has to become 0 completely. When 4 roots are located symmetrically with respect to origin, because 4 are on the j omega axis, S cube rho has to be 0. When S cube rho is 0, we form the auxiliary polynomial from S power 4 rho and we differentiate to complete the Routh array. So, Routh array of the system S to the power of 4, 3, 2, 1, 0, it becomes 1, 5, this is 0, 5, 0, this is k plus 4. Now completing the Routh array, S cube rho, the coefficients becomes, by differentiating it, it becomes 4s cube plus 10s to the power 1. We can replace this with 4 and we can replace this with 10. And then moving ahead to complete these things. S cube rho 0 as well as S power 1 rho 0 may also be possible. For 4 roots to be symmetrically located with respect to origin, either S cube rho is 0 or S cube as well as S power 1 rho, both have to be 0. S cube rho 0 for simple imaginary and this is for multiple imaginary. But question is, all 4 have to be imaginary. It means there should not be any sign changes further. Because S cube rho 0 means 4 roots are symmetric to origin and therefore can be anywhere, only on real axis, only on imaginary axis are both possible. But since the question is mentioning very clearly that they have to be imaginary, so there should not be any sign changes. That means that this particular thing has to be greater than 0. This can be either 0 or greater than 0 but should not be less than. The same condition apply. Upon solving this, we get the answer to be minus 4 less than k less than or equal to 9 by 4 is the answer to the question. Proceeding with this question, root locus diagram of a system is given. The question is to find the possible open loop transfer function. It is very clearly seen that from one point in S plane, which is on the real axis, 5 root locus branches are emerging. 1, 2, 3, 4, 5. This can possible only when we have got 5 poles in the system at the same point, because root locus branch departs from open loop pole and number of root locus branches is equals to number of open loop poles or number of open loop zeros, whichever is greater. So here we have got 5 branches. So let us consider that there are 5 poles in the system and all are originating from the same point. So this system has got 5 poles and all are located at the same point. So 5 multiple real poles are there. So there is only one option that can match to that. It is this. The only option that matches to this question is B. That's it. So these are the 3 questions. The further questions will be taken by mistake.
Okay, hello all dear students. So let's discuss further questions from the beautiful subject that is control systems. So okay, so one question from this first chapter. This is the question. Let's read the question first, then we are going to solve the question. Here examiner clearly mentioned that ET, that is nothing but RT minus YT. Where is YT? This is your YT. Okay, so here it is what? YT. So where RT minus YT, RT, that is this, minus YT, means you are getting E of t here. I can say like this, E of t you are getting here, and RT is equal to 0. Okay, okay dear, here we are not going to consider RT. RT is 0. These questions are memory based questions. So as per the response given by the students जो आज एग्जाम दिए हैं उनके अकॉर्डिंग हमें जो डाटा मिला है उसमें इस तरह से इंफॉर्मेशन थी कि RT हमारा क्या है 0. RT is 0. Okay, so now what is the question? Find ESS. Okay, find ESS. Find ESS due to unit step disturbance. Okay, due to unit step disturbance. Okay, so means I have to find out. There are two methods. First method, with the help of block reduction technique you can proceed. with the help of block reduction technique, and this is the very standard format in our discussion during the class itself. Many times we have discussed this particular block diagram where a disturbance is there, error is there. Even if they are not going to give this information, we are going to proceed in the same manner for finding ESS. Okay, so with the help of method 1, that is block reduction technique, what we are going to write, I am going to write here E of S. Okay, I am writing E of S. Okay, I am writing here capital E upon S divided by D of S. What it will be? Here don't forget, my dear, this is the sign minus. So if I am considering this as a G1S, okay, if I am considering this as a G2S, okay, so what will be ES upon DS? It will be equal to minus sign. Because of this, you know very well, G2S divided by 1 plus G1S into G2S. Okay, so let's solve this question now. Okay, now we are going to solve this part. Here it will be equal to what? Here it will be equal to minus G2 by S. Okay, G2, this is G2, so I am writing here minus 1 upon S plus 10 divided by 1 plus G1 into G2 means what it will be? It will be equal to 10 divided by S plus 10. Okay, so now here we are getting what? Here we are getting ES divided by DS is equal to minus 1 divided by S square plus 10S plus 10. Okay, this is nothing but your ES divided by DS. Okay, now you know very well, I want the ESS. That ESS, that is nothing but limit t tends to infinite E of t. Okay, but with respect to the Laplace, you guys know very well, with respect to Laplace, you all know very well. Okay, you all know very well, it will be limit s tends to 0 s multiplied by E of s. Okay, what is ES? ES is nothing but what? Minus DS upon this function. So I am now going to write here, ESS is equal to limit s tends to 0 s multiplied by minus DS minus DS and then divided by the function we have, that is nothing but what? S square plus S square plus 10S plus 10. Okay guys, so this is our ESS. What will be your DS now? Here examiner has clearly given you unit step disturbance, so obviously you will put here what? 1 upon S. S is going to cancel. Then what is going to happen? I am writing here minus SS cancel, this is nothing but minus 1 divided by, if you are going to put S equal to 0, this part going to be 0, this part going to be 0, but denominator is nothing but 10. So denominator is nothing but 10. So our answer is minus, yes, our answer is going to be, I am writing here, okay, I am writing here ESS, our answer is going to be minus 1 by 10, means ESS is nothing but minus 0.1. Okay, so our answer is nothing but, this is numerical answer type question, so you are going to apply minus 0.1 as the answer of this particular question. This is nothing but method number 1, who know very well the block reduction for this particular standard block diagram. Okay, what can be the next method. Okay, I am going to introduce here now the method number 2. Now I am going to introduce here method number 2, because these things depends student on student, that one student is going to be use the block technique and another is going to proceed through SFG. So now we are going to see with respect to SFG. What is this? This can be considered as output point. This can be considered as input point. Obviously we are not going to observe Y. Obviously we are not going to observe R. So what will be the forward path? With respect to signal flow graph, what will be the forward path? This path can be the forward path, no? This path from input to this output. This can be the forward path. I am not giving any trick. This is not the trick. We all know very well the way to find forward path. So this is nothing but forward path, that is considered as P1. Okay, only one forward path. How many loops are there? 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 This is your input, this is your output, and then again. So what can I say? This is nothing but the loop. This is nothing but the loop. This is nothing but the loop L1, and that loop is nothing but the part of the P1. So you guys know very well what will be the formula for transfer function. For the transfer function, the formula will be equal to P1 delta 1 divided by delta, where as per the information I have discussed, delta 1 is now 0, means 1 minus 0, that is nothing but 1, means it is exactly going to be equal to what? P1 upon delta. Okay, so if you are going to proceed further, what is P1? What is the gain of the forward path P1? This is nothing but the gain of the forward path, where minus is coming. Don't forget this minus sign. Every time in class also, when we used to teach, we used to consider this point very strictly as a note, that we should not forget. So what will be the gain of the forward path? This is nothing but minus of this, that is nothing but what? Minus 1 upon s plus 10 divided by delta is nothing but what? 1 minus sum of all the loops. Sum of all the loops. 1 minus sum of all the loops. How many loops are there? Only one loop. That is nothing but what? This. And what is the loop gain? Minus 10 this function, and then the loop is going to complete. So what can I say? I can say minus 10 divided by s plus 10. Okay. So what is actually transfer function for this particular discussion? That is nothing but with respect to input D, output E, means we are calculating directly indirectly what? Directly indirectly what? The same, obviously, ES upon DS. Now if you are going to calculate this, what it will be? Minus 1, yes, minus 1 divided by what it will be? S square plus 10s plus 10, s square plus 10s plus 10. Obviously we are getting the same, because through the block reduction technique or through the signal flow graph, obviously the conclusion must be same. So this is nothing but the next method to calculate the ES divided by DS. With the method 1, with the method 2, we have calculated ES upon DS, where DS given already 1 upon S. So what will be ES? ES is nothing but that DS into this function. DS you put 1 by S. Again you will apply the concept with respect to the steady state. ESS is nothing but limit S tends to 0, S into that ES. So in the same manner we are going to proceed further as we proceeded here in the method number 1. Like that, if we calculate, our answer is going to be minus 0.1. Okay, so I hope this question looks like easy for you all. Let's discuss the other question. Sir has already discussed this question, so we are going to proceed for the next question. Yes, this is now another question. Yes, this is the another question. As per the information we have, I am just going to check that it is s square plus s plus 1. Okay, so as per the information we have, consider two system G1S. One system is nothing but G1S, another system is nothing but G2S, another system is nothing but G2S. This is MSQ. Sorry, this is I think MSQ or MCQ. Forget this. Maybe MSQ or MCQ. As per the information we are getting from the students. We have considered that particular question, and also one doubt amongst the student that sir may be here 10, may not be here 10. So what we are going to do, we are going to focus as per the information, we are going to focus mainly on the characteristics equation. दोस्तों स्टूडेंट ने जो इन्फॉर्मेशन हमें दिए हैं, जिन्होंने आज पेपर अटेम्प्ट किए थे, उन्हें जो याद था उससे जो हमें डेटा मिला है, और अब एग्जाम के बाद आपको सपोर्ट करने के पर्पज से जो क्वेश्चन को फ्रेम किया गया है, उस डिस्कशन में थोड़ा बहुत डेटा का चेंज हो सकता है, बट द आंसर इज नॉट गोइंग टू डेविएट टू मच बेस्ड ऑन द डेटा वी हैव. तो इस क्वेश्चन में ये 10 का इन्फॉर्मेशन में उतना अच्छा क्लियर नहीं है, बट हाँ इतना कंफर्म है कि ये कैरेक्टरिस्टिक्स इक्वेशन ट्रांसफर फंक्शन नंबर 1 की है और ये है कैरेक्टरिस्टिक्स इक्वेशन फॉर 2. सो लेट्स डिस्कस द क्वेश्चन. ओके, परसेंटेज पीक ओवरशूट फॉर बोथ द सिस्टम इज सेम. परसेंटेज पीक ओवरशूट फॉर बोथ द सिस्टम इज सेम के लिए हमें जीटा पता करना पड़ेगा. यू ऑल गाइज नो वेरी वेल. कम टू द नेक्स्ट पॉइंट, स्टेडी स्टेट आउटपुट फॉर बोथ द सिस्टम. ओके, सो हमें स्टेडी स्टेट आउटपुट पता करना पड़ेगा. स्टेडी स्टेट आउटपुट पता करना पड़ेगा फॉर बोथ द सिस्टम. स्टेडी स्टेट आउटपुट फॉर बोथ द सिस्टम हमें पता करना पड़ेगा. नेक्स्ट है डैम्प्ड फ्रीक्वेंसी इज सेम फॉर बोथ द सिस्टम. मतलब हमें ओमेगा डी दोनों के लिए पता करना पड़ेगा, तब जाके क्रॉस चेक होगा कि भाई स्टेटमेंट सही है या गलत है. फिर स्टेडी स्टेट एरर इज सेम फॉर बोथ द सिस्टम. स्टेडी स्टेट एरर इज गोइंग टू सेम फॉर बोथ द सिस्टम. अगर हम डेटा की बात करें तो यहाँ पर जो स्टेटमेंट है, आई एम गोइंग टू correct this. The first is with respect to peak overshoot both the system. Okay, next is same steady state value, steady state output for both the system. Yes, next is same omega d. Third is same ts. Sorry, as per the information here, the question is same for ts for 2% criteria. The statement as per the information we have, same ts settling time ts for 2% error criteria. Okay, so these three statements, so means settling time, next is nothing but what? Settling time. Okay, settling time ts. 4 things we have to calculate. Okay, so let's discuss this. Just a minute. Here I am going to add the slide and going to solve that. Okay, so first of all we are going to consider with respect to G1s here, and then we are going to consider with respect to G2s. I am going to take the function that is 10 divided by s square plus s plus 1. G2s is nothing but 10 divided by s square plus under root 10 s plus 10. Okay, so let's continue. We are going to compare the characteristics equation. We are going to compare the characteristic equations with respect to s square plus 2 zeta s square plus 2 zeta omega ns plus omega n square. Okay, so for this system what will be omega n square? That is nothing but 1. So we are getting omega n is nothing but, obviously we will take only positive, that is omega n equal to 1. And for this what can we say? Omega n square is equal to 10. Obviously we will take only positive, that is omega n is equal to what? Under root 10. Come to the next point, that is 2 zeta omega n, that is nothing but what? 1. So we are getting zeta is equal to what? 1 upon 2 zeta, 1 upon zeta is equal to 1 upon 2 omega n, that is 1, means it is nothing but 0.5. Okay, so come to the system number 2, that is 2 zeta omega n is nothing but under root 10. So we are getting here zeta value. I have calculated that value and I am using that calculated data. That zeta we are getting something here, what? Here it is root 10 divided by 2 root 10. Okay, means 1 by 2 means 0.5. Okay, so come to the next point. This is nothing but zeta, this is nothing but omega n. Now it is the time for omega d. What is omega d? Omega d, I am writing the formula here in the middle. Okay, here what is omega d? That is nothing but omega n under root 1 minus zeta square. Got it? So we are going to calculate omega d, that is nothing but what? Here 1 under root 1 minus 0.5 square. We are going to calculate omega d. Now the next, that is omega d is equal to omega n under root 10 into 1 minus 0.5 square. So without wasting time, the calculated value of omega d I am going to write here directly. The calculated value of omega d, it is nothing but 0.866. Okay, and here the calculated omega d is, calculated value of omega d is something 2.7386. Okay, so this is omega d, this is omega d. Now as per the statements, first statement, percentage peak overshoot for both the system is same. So if you are going to observe here, what is zeta? Zeta is nothing but 0.5. What is zeta? Is nothing but what? 0.5. With respect to that, you can say that yes, it is going to be the same, the percentage value is going to be the same, percentage peak overshoot for both the system is same. Now come to the next point, steady state output for both the system. Steady state output with respect to step input. As per the data we have here, it was with respect to step input. So now what will be your C of S? What will be your C of S? C of S is nothing but Cs upon Rs is this, means 10 multiplied by Rs is nothing but what? 1 by S divided by S square plus S plus 1. So the steady state value of the response is going to be limit t tends to infinite, or I can say s tends to 0, s into C of S, s into C of S, means I am writing here limit s tends to 0, s multiplied by 10 by s divided by s square plus s plus 1. Okay, so what is going to happen? The s is going to cancel. Now you put 0. So here you are getting CSS is nothing but 10. Okay, it all depends on the data you have provided us. Okay, so now come to the next point. Here with respect to this system, CS is equal to 10 multiplied by 1 by S with respect to unit step input. Now here S square plus S plus 1, we want the steady state value. So again the same, that is limit t tends to infinite C of t, or I can say limit s tends to 0, s into C of S. Okay, so you guys know very well, this s going to cancel, and then it is going to be 10 divided by 10. Here it is 10. Okay, here it is 10. Here as per the data, just a minute. S square plus under root 10s. Okay, s square plus under root 10s. Okay, so let's continue. S is going to cancel, you put s equal to 0, so here it will be what? S equal to 10. So now here we are getting the steady state value equal to 1. अब यहाँ पर ध्यान से देखिए, ये जो डेटा है ये जो डेटा है इस पर भी स्टेटमेंट बेस्ड होगा। हमारे पास जो स्टेटमेंट है उसमें मैंने आपको स्टार्टिंग में बताया, ये आप लोग कंफर्म करेंगे और जब आप कंफर्म कर लेंगे कि हाँ सर ये 10 था या कुछ और था, उस पे भी आधार होगा इस पर्टिकुलर स्टेटमेंट का। अभी अगर हम इस पर्टिकुलर स्टेटमेंट के कंक्लूजन को देखने की कोशिश करें तो जो स्टेडी स्टेट वैल्यू आ रही है अभी 10 आ रही है और इस पर्टिकुलर सेकंड सिस्टम की 1। सो इफ यू आर गोइंग टू कम हेयर, percentage peak overshoot for both the system is same. Yes, steady state output for both the system is same, so it is going to be wrong. Damped frequency is same for both the system. Okay, come here. This is the damped frequency for one system and this is the damped frequency of the another system. तो अगर हम देखें यहाँ पर तो damped frequency तो सेम नहीं आ रही है. Same TS for both the system. Okay, settling time. Guys, if you are going to observe, here zeta is nothing but 0.5. Here zeta is nothing but what? 0.5. अगर zeta 0.5 है मतलब 0 to 1 है, मतलब सिस्टम क्या है? अंडर डैम्प रिस्पॉन्स है। अगर अंडर डैम्प है तो जो सेटलिंग टाइम होगा, अगर हम सेटलिंग टाइम की बात करें तो जो सिस्टम G1 है और यहाँ पे जो सिस्टम G2 है। ओके, सो G1 के केस में सेटलिंग टाइम हो जाएगा क्या? 4 अपॉन जीटा ओमेगा एन। यहाँ सेटलिंग टाइम हो जाएगा क्या? 4 अपॉन जीटा ओमेगा एन। जीटा दोनों के केस में, इन दिस केस 0.5, इन दिस केस 0.5. Okay, so what can I say? Equal to 4 divided by 0.5 multiplied by is equal to 4 divided by 0.5 multiplied by, what is omega n for this? What is omega n for this? 1. For this root 10 means here it is 1, here it is root 10, means obviously this is nothing but of the system 1, this is of nothing but the of system 2. So settling time of 1 is not going to equal to the settling time with respect to 2% error criteria. हमने यहाँ पर 4 लिया है और फिर भी अगर हम देखें तो settling time सेम नहीं आ रहा है. अगर हम given statement पे जाएं जो as per the information we have, same TS for 2% error criteria, तो ये वाला स्टेटमेंट जो आप देख रहे हैं ये डी ऑप्शन गलत है. Here in this particular question B, C, D is going to be wrong, only the A option is going to be the right. So like this we have discussed the question. Here the question we have discussed with respect to control system, all the questions we have discussed, Now I welcome the faculty members of other subject and they are going to discuss the questions and the solutions. Thank you all.
Good evening, dear students. I hope you did well. The network analysis you are going to discuss here. You received the total 5 questions. In these 5 questions, you are going to discuss only 4 questions. Why? Because the 5th question data is not available. According to previous year, now the questions here, the level is moderate to easy. Okay, we start now. The question number 1 here is, the current I flowing through the 2 ohm resistor is, here the ground is given, suppose here is given information, according to the given information is ground is not given. If your ground is not given, the current flowing the 2 ohm resistance is directly you can say 0 amperes. Why? Because there is no return path. But if your ground is, if here it is a grounded, then the current will flows. Why? Because here the 2 are grounded means the current will flows. There is a return path. But you are getting data from that. Only one is grounded means from that you get a current I is equal to here is 0 amperes only. If it is both are grounded, then go for the nodal analysis. You put a V1 here and V2 here, write a KCL equations and you get a V1 and V2. From that I is equal to V1 minus V2 by 2 ohms.
Good evening, dear students. Come to next question. Now correspond this example, what is our requirement is in the given question he asked you to find out this I value. He asked you to find out I value. Now to find out I value you can go for any approach. You can apply the nodal analysis or you can apply the mesh analysis, any method you can apply. But in this example if you go for mesh analysis you can conclude the answer easy way. You can simplify the calculations. For this particular example, let us assume the loop current of first one is the I1. Here I1 means indirectly I only. Now the loop current of this one, let us assume this one is I2. Now for this example, without writing any equation, directly you can conclude the I2 value. Here this 1 milliampere and I2 both are in the same direction. Then what about this I2 is equal to 1 milliampere. But what is the requirement is the I value. To find out I value, can you write the KVL equation for this loop 1? Can you write the KVL equation for this loop 1? Now if you write the KVL equation for this loop 1, lower potential to higher potential voltage rise. Now I1 circulate in the 2 kilo ohm and 2 kilo ohm, but the total resistance is the 4. In this example for 2 kilo ohm resistor, I1 is the downwards, I2 also downwards, both are in the same direction. Same direction means what is the sign is a plus I2. What is the requirement of the I? I means indirectly which one here I1. Previously we already concluded the I2 value. What is the I2 equal to how much here? 1 milliampere. What about this I2 equal to 1 milliampere? Now by simplifying this one, what is the unknown is one is the only I1. Simplify karo. By simplifying this one, checked out what is the correct option for this is the 0.75 milliamperes. Here the I1 means indirectly I only.
Now third question, this is based on the steady state AC analysis. The question is the steady state current I of t of a network I shown in the figure. I of t is given in this figure. The circuit is given V of t is equal to sin t. Okay. Now the question is asking what is the element. Here the impedance is given here. 1 ohm resistance in series with the Z. So what is the element inside the in this block box? That is inductor or a capacitor. The value of inductor is maybe root 3 or capacitor value may be root 3 or 1 Henry or 1 farad. Okay. Based on this, directly you can say the element is inductor. How it is? The current is here is a lagging now. Here starts from here, this current is lagging from here. So the element is inductor now. A hone ke baad now, how to find this inductor value? The value of the current is here is a 1 by root 2. The maximum value of the current is 1 by root 2. I is equal to here V by Z. Here Z value, V is equal to how much here now? This is sin t. So the maximum value is 1 angle 0 directly you can say. So Z value is how much here now? From this directly you can say Z is equal to root 2. Then only the current I maximum value is 1 by root 2. Z value is here R plus JXL. Based on the current is lagging. So inductor R plus JXL. This magnitude is equal to root 2. So what R square plus XL square under root is equal to root 2. From this you substitute the values. Now substitute the values here. R value is 1 is given, 1 square plus XL square is equal to square root both sides. Here the 2. Here XL is equal to 2 minus 1, the root is 1. Here XL is equal to omega L, omega is equal to 1 is given information from this sin t. So L is equal to 1 Henry. The option is here. Here B is the answer for this question. Okay. And another question also there. So based on the locus diagrams, but is the data is not available exactly. So that is also very easy actually given from the GATE data. You would substitute omega is equal to 0, you get a R1 value, and also omega is equal to infinite, you get a R2 value. Okay. So this total questions from 2 questions from the steady state AC analysis.
Come to the next one. Now this is one of the good question. The question is not very complex, but so much of data is available. But by using simple logics, we can easily conclude the answers. To conclude the answer for this one, you can go for so many approaches. But one of the easy approach is our Thevenin's theorem. With help of the application Thevenin's theorem, we can easily conclude the answer. First, let us see what is the given question. Now, corresponds example here, this entire portion. Now, it is one entire complex network. For this complex network, across the AB terminals, one variable resistance is given. Now, whenever the resistance varies, at that instant, respect to this voltage and current characteristics are given. Voltage and current characteristics are given. In this particular example, here the voltage changing from 5 volts to 4 volts. Now, at that instant, the current was given as this 4 milliamperes. 4 milliamperes. Later, what is the statement given? Across the AB terminals, if this variable resistance replaced by the combination of the 1 kilo ohm and 10 volts, now we have to find out the respect to I2 value. You have to find respect to I2 value. Let us see how can you apply this Thevenin's theorem concept for this question. Now, for this example, first let us focus on the given graph. In this given graph, in the case 1, first let us take this I2 equal to 0. First let us take the I2 equal to 0. Now, I2 0, current 0 means we can call this as an open circuit. Open circuit, इधर देखिए, whenever this I equal 0, we can measure the corresponding voltage. With help of the given graph, we can measure the voltage. What is the open circuit voltage equal to 5 volts? Open circuit voltage equal to 5 volts. VOC you got the 5. Now come to case 2. Now case 2, again come to the given data. Now correspond case 2, let us focus on the calculation of R Thevenins. Again, to find out the R Thevenins also, we can go for the so many approaches. One of the easy approach for this one is in the question itself given what is the shape of the graph is a linear. What is the shape of the graph is a linear. Now for this particular example 5 to 4, that means for 1 volt interval, what is the variation current, how much you got here? 4 milliamperes. 4 milliamperes. Now for this example, if I extend this graph, if I extend this graph, at one particular value the current, it will intersect with the x axis, it will intersect the x axis. इधर देखिए, now 5 volts to whenever it is intersecting this x axis, what is the voltage at this point is a 0. That means sir, what is the variation voltage, how much you got here, 5 volts. With help of the linearity concept, for 1 volt interval how much current variation we got here, 4 milliamperes. Then for 5 volt interval how much current we get here, 20 milliamperes. Now with help of the linearity concept I am concluding here. Now again come to this point. Now correspond this point, if you observe here, what is the voltage at this point is a 0. Voltage 0, voltage 0 means we can indicate this as a short circuit. We can indicate a short circuit. Now short circuit current is also known. Short circuit current is also known. That means here in this example, the respective short circuit current is equal to 20 milliamperes. In the previous step, we already concluded VOC. VOC is known, ISC is known. Can you find out the respective R Thevenins? This R Thevenins is equal to VOC by ISC. VOC by ISC. Now, if you substitute the respect to this VOC and ISC, check करोली, R Thevenins is equal to 250 ohms. R Thevenins is equal to 50 ohms. And one more thing, you will get one more doubt here. You will get doubt as a, here the slope is decreasing, you will get doubt as a resistance will be negative. मगर इधर negative resistance नहीं लेना है. Reason क्या है बोले तो देखिए इधर. Actually I2 has to come outwards. Actually I2 has come outwards. But in our given question, how it is given as a inverse? It is given as a inverse. That is why here finally we have to take this resistance as a positive only. We have to take the resistance as a positive only. That means here for this entire complex network, we got the Thevenin's equivalent circuit. Now what the question, in the question what is saying, across the AB terminals, what the new resistance is 1 kilo ohm and voltage is the 10 volts. Voltage is 10 volts. Can you develop the Thevenin's equivalent circuit now? In the question itself given, across the AB terminals, 1 kilo ohm, what that voltage is the 10 volts. R Thevenin's. Now 250 ohms, 250 ohms means we can write this as a, in terms of kilo ohms, 0.25 kilo ohms. Now what about this VOC, open circuit voltage? Open circuit voltage is equal to 5 volts. In the given example, what is asking the I value? What is asking, find out the I2 value. Now if you come to this I2 value here, इधर देखिए, plus similar polarities subtraction, 10 minus 5. How this 1 kilo ohm and this 0.25 both are in series, then what is the total resistance here? If you simplify this one, then what about the I2 equal to 4 milliamperes. Okay students, thank you.
Welcome students, welcome to the digital electronics session. Here digital electronics, in this we are having the questions like, this is the first question you are having on the screen related to the multiplexer. They asked the question. It is expected only in the combinational circuits. The very important topic is multiplexer, and in the multiplexer the way the question asked is so simple way, because there is no logic also in this one. As you know, C, D, S1, S0, these two are the select lines they gave, and for those two select lines C, D, these are the two variables they are using here, and here the inputs are A0, A1, A2, A3. What should be these to get the XOR output? That is the question they actually asked. As you know, the general equation, how we are actually writing for a multiplexer, in that way only simply we should write the equation and we will get the answer for this. In a multiplexer, actually they can ask somewhat in a little bit more logical questions also possible, but they asked this is a very simple question in the multiplexer. How we can get the equation, we will see that. That equation is, for example, you check it. Yeah, in this one, if you observe, as you know, here the CD are the select lines. No, for the I0, we are going to get the expression like this. Just carefully check this one, very simple one, this one, like this expression, this F is, we are going to have like this, F is equal to here C bar D bar, like that we can say that, okay. C bar D bar into this will be the I0. That means C bar D bar is going to select I0. So like that we can write here, and this is C bar D, that is into I1. This is CD bar, that is nothing but I2, and this is CD, that is nothing but I3. So here from this one, what we want to tell me, here we are actually in need of XOR expression. So XOR expression means C XOR D. If you want to get there, then what the terms should be remain there and what terms should be cancelled out there, that thing we should focus on that. If you observe here in this one, here in this particular thing, this expression should be cancelled and this also should not be there, then this should be 0 and this should be 0, and the remaining things will be this and this. That means C bar D plus CD bar. Is it not that the C XOR D we are getting? So in order to get C XOR D here, we should get here I0 in the place of I0. Here for this one we should get, this is nothing but, we should have this one as 0 and this one as 1, this one as 1, this one as 0. If you put like that only, here we are going to get the C XOR D. So it is so simple way, by observing the expression, in the expression, by seeing the terms there, easily we can identify that what term should be remain there and what term should be cancelled there, so that we can get the answers so easily. This is about the question related to the multiplexer, where the question in that by writing the simple expression itself we can get the answer. So that is about multiplexer question. Now we will see the next question here. Right. Yeah, this is another question we are having, like gate D gives output A plus B bar. For inputs A and B, which of the following statement is correct if 0 and 1 are available? This is a very beautiful question, really speaking, because so many confusions and misconceptions will be there for in general students, not actually for our students, because we discussed also especially about this point only in our class, in our classes there, where this is actually comes under the category of functional completeness. Because the functional completeness point of view, if you solve this one, it is so easy the thing, because as you know, A plus B bar, this one if you observe, this is actually implication operation. As you know, A plus B is the OR operation, but any one of the variable is complemented and having the OR operation, that is the implication operation. So inhibition and implication, these are the two operations where we are having logical NOT and OR, NAND, NOR, XOR, XNOR, these operations. In addition to that, we are also having inhibition, implication, like that the two more operations, logical operations. Generally students, they won't focus on these two, but based on these, especially a beautiful question was asked here, where this is implication operation. Inhibition is A dot B bar, that is another thing, but here in this question they gave the A plus B bar. Now you see how we can make this one, because here you see AND cannot be implemented, NOR gate can be implemented, NAND gate can be implemented, OR gate cannot be implemented. That means by that A plus B bar expression, what the gates that can be implemented and what cannot be implemented, like that the question. Now without writing the logical gate and all, how to solve this one? By using the functional completeness, we will see that. Okay. Now carefully observe that. Here let me consider that expression only here. F is equal to, say for example, that expression is, we are having this one A plus B bar. So that is actually the function is of F of A B, that is nothing but A plus B bar we are saying, no. So functional completeness point of view, how to make it is, if we are able to get NAND operation like that only, otherwise the NOR operation by that expression, we can say that is the universal operations that we are able to get, then we can say it is a functional completeness. To check the NAND operation, NOR operations, we should follow like this. That is first. That means we want to check whether it is going to give the NAND or NOR. Among these, any one of the operation we are able to get, then it is functional completeness. So for example here F of A, both you keep here, A plus A bar we are getting. That means we are not going to get there like that. So that here this is one we are having. So that means NOT operation is not able to get by this one. So it is not at all functionally completed. So implication is not functionally completed. Yes, students used to have a doubt about it. It's a inhibition, implication. These are functionally completed or not. Functionally completed provided some other things also they should mention in the data. Yes, that is a very crucial and interesting point there. Here, if you check this one A plus B bar for the NOT gate, when NOT gate only we are not able to get, then AND gate, OR gate, even though we are trying for that, we are not able to get the universal property there from this one. That means for the functional completeness of A plus B bar, another things also, the data also should be given, then only we can say that this implication is functionally completed. We will check that one, how it is. That's why in the question they gave very interestingly the point here, if you observe in the question, this one is mentioned. This is very crucial role playing here. 0, 1 are available. This is actually changing the entire question actually here, because 0, 1 given, then it is going to have the functional completeness. We will check that one here, see that how it is going to be. For example here, in this one we are having we are not able to get, but when it is given 0 or 1, it is going to be functionally completed. Because when you mention any one of them as 0 or 1 here, say for example here F of, here if you say that 0 and here this is place of B, if you write B only, then A plus B bar, in that one what you will get 0 plus B bar, that means we got B bar, that is NOT gate we are able to get, not we are getting. Once we got the NOT gate, then we can write here F of A, and in the place of B we can write as B bar, then we will get A plus B bar B, so that it is A plus B. so that we are getting the OR operation also. So not operation, OR operation, both when you are getting, simply we will get it is nothing but NOR it is we are able to get. Once NOR gate we are getting by that function, yes, NOR gate you know that universal logic gate. So NOR gate only we are getting means any function can be easily implemented by that expression. So that all the logic gates easily can be implemented by that. So that if you observe that in that only, so once we got the NOR gate, you check this one, it is universal gate means what we can say here, tell me. Yes, this is NOR gate can be implemented. Once NOR gate implemented, NAND also will get, OR also will get, and also will get. So then A, D options here they mentioned cannot be, no. That's why we cannot say that A, D are A and D, these two options are wrong here, because they mention here cannot be implemented, because actual thing is all the logic gates and or NAND NOR all the logic gates can be implemented by these, because we got no NOR operation implementation by this A plus B bar. That's why you understood now A plus B bar is the implication operation, and that implication operation is universal operation provided this particular 0 1 availability based on this only, otherwise it is not in functional completeness. That's why the functional completeness of this function A plus B bar implication is going to get the validity if other data like 0 1 availability based on that. That's why this question is a beautiful question, you can say that. Got it? Right. Next question we can see here. This is the question, another one we can say. It is so simple question we are having, no, x plus yz they are asking, equivalent function of this one they are asking. You see this one, how simply this can be solved. This one if you observe, this b is anyway valid because f x plus yz, no, this is, if you write dual form of that, if f is valid, its dual form also valid, so that we can say x dot y plus z, so that it is nothing but x dot y. Okay, okay. So you understood, no? That means we can say that this color, let me say that this one again. Okay, next question we will see that, afterwards we will come back to this one. This particular question they asked the frequency input is f naught, because that particular expression question we can very simply solve it like by writing the dual expression also we can solve that one. Otherwise I will get again the question here on the screen, then we will see that. But before that let me consider this question here. The frequency of input f naught, somewhat f naught given here, complete data not given here, but they are asking here the question, here they are asking the question what will be the output. That output, to get it here, it is a 2-bit counter. 2-bit counter means we are going to have the conditions like 0 0 0 1 1 0 1 1, isn't it? So in this particular one, this is LSB and this is what, MSB. So LSB is nothing but 0 1 0 1, and that 0 1 0 1 when you are getting here, for the 0 state here the same state is going to be retained, but for the state of 1 it is going to have the change of state. That means here this particular thing, this particular LSB is 0 1 0 1 means here we are going to have this particular output only one time, the state among the 4 states of 0 1 0 1, only 2 times only it is going to have the change of state, and 2 times it is going to retain the same original state. That means we can say at this particular output the frequency will be of f by 4 we are going to get, f by 4 we are going to get here, okay, f by 4 we are going to get. So simply like that you can get that idea, because here very simple one, this is diagram seems to be this much like that, but here this particular output is of 0 1 0 1. For the 0 state of JK flip flop the same state is going to be retained, for the 1 state it is going to get the toggle operation, so that here 0 1 0 1 is going to cause among the 4 states only we are having the 2 times only the toggle operation is going to occur. So based on that the frequency we are going to have the division of 4. For the input frequency f naught, there we are going to get the f naught by 4 like that. You understood now this? Right. And another question of that one that missed the screen, that question is of so simple, very simple, we will see that within 1 minute, okay, right. एक मिनट रुको. Yeah, this is the question actually missed on the screen, no? Yeah, this is very simple, this expression for this one which will be valid like that. Yeah, you can see even B and C also. Here x you take the common, so 1 plus 5 will get this one. You see, for example, I will write here. For this one, you take the x as common, we will write this is 1 plus 5 plus xz. So that is going to be nothing but this is 1, no? So that x plus, we are going to have this is nothing but this x, the options are actually this is yz, they go x plus yz we are going to get here. So this is also correct like that because options not at all clearly mentioned here, but I think here it is y, it is there. So based on that we are having that is nothing but you take the x common, so that 1 plus y is we are going to have 1, so x plus yz. So simple question it is. And x plus yz, it is already direct this we are having a Boolean law, no, that is nothing but x plus y dot x plus z also. It is so simple. So two options are actually correct like that. This can be solved very easily also by the students, okay. Anyway, right, thank you.
Good evening, dear students. This is Iftikhar Ahmed, faculty for analog electronics. I will be discussing here solutions for analog circuits along with my colleague Mr. Rajkumar sir. Totally in this GATE 2022 we have got 7 questions from analog electronics, and out of the 7 questions we have data available for 6 questions. For 1 question we do not have data available, so we will be discussing here about 6 questions. And out of this total 7 questions, there are 3 questions based on op-amp, there are 3 questions from MOSFETs, and 1 question is based on diode circuits. And I will be discussing 3 questions, and my colleague Mr. Rajkumar sir will be discussing other 3 questions. So let us get going with the first question. This first question is based on an astable multivibrator. In our classes I have always told you that this year's GATE paper you can definitely expect a question from positive feedback applications of op-amp. So this question is based on positive feedback application of op-amp. We call it astable multivibrator or square wave generator. And in this question we have to find out the difference between maximum capacitor voltage and minimum capacitor voltage. Now in this astable multivibrator I will first of all show the output. Output will be square wave, and capacitor will be like charging and discharging. Whenever output plus 15, capacitor will charge, and when output is minus 12, capacitor will discharge through this resistor. So this concept we all have in our mind. So keeping this in mind, I will show here the waveform. let me draw here the waveform for output. This will be the output waveform, which is a square wave. It will vary between 15 volt and minus 12 volt. And then on the same graph I will show the waveform for capacitor voltage. You can call it Vc max and Vc min. Now in case of capacitor, there will be charging and discharging action. When output is plus 15, capacitor will charge exponentially, and when output is minus 12, capacitor will discharge. So in this way the waveform for capacitor will look like. It is an exponential increase and exponential decrease. Now this Vc max will be equal to upper threshold voltage, and Vc min, it will be equal to lower threshold voltage. Now if you look at the circuit diagram, you can notice from here that when output is plus 15, if output is plus 15, then this diode D1 will be on and D2 will be off. Okay, some new sense is created in the question by including diodes. Every year something new will be there in the GATE paper, right? So here we have got two additional diodes. When output plus 15, that diode D1 will be on and D2 will be off. Okay, let me just mention it here. If output equal to plus 15 volt, then D1 on and D2 will be off. And when such situation happens, then this diode is becoming like a short circuit. So I will replace it with a short circuit. This becomes a short circuit and this diode will become open circuit. And now these two resistors, they come in series. It will become a resistance equal to 2R, and this resistance will become dead because there is a short circuit in parallel, and you will have only resistor R remaining here. So the circuit will look like this. I will show only connection towards non-inverting terminal. You will be having a resistance equal to R here, and this will be 2R, and output is plus 15 volt. Now if you calculate upper threshold, that is nothing but your Vc max, maximum capacitor voltage. It will be equal to upper threshold voltage, and that can be calculated through voltage divider concept. 15 into R divided by R plus 2R, 15 into R divided by R plus 2R, and this will be equal to 5 volt. So this is maximum capacitor voltage. In a similar way, we can obtain minimum capacitor voltage. Minimum capacitor voltage will happen when output becomes minus 12, and from the circuit we can observe when output is minus 12, D1 becomes off and diode D2 becomes on. And now the connection towards non-inverting terminal can be shown in this way. There are two resistances here, and here the diode D2 is becoming on. So one resistance R, it will become dead. You will have only resistance R here. This is output equal to minus 12, and now this resistance will become 2R. And now if you calculate lower threshold will become minimum capacitor voltage. So minimum capacitor voltage is equal to lower threshold voltage, and that will be minus 12 into this 2R divided by 2R plus R, and this will be equal to minus 8 volt. So in this astable multivibrator, maximum capacitor voltage is 5 volt and minimum capacitor voltage is minus 8 volt. Now we have to find the difference Vc max minus Vc min. Now this difference, it will be 5 minus of minus 8, and that is equal to 13 volt. So for this particular question, the correct answer Vc max minus Vc minimum should be equal to 13 volt. Let us move now to the next question. The next question is from active filter topic. Now from op-amp we have got 3 questions, one question based on astable multivibrator and other 2 op-amp questions, they are based on active filters. In our classes I have always told okay, there can be a question from active filter also, and it has happened here. There are 2 questions from active filter topic. Okay, I will be solving one question here. Now in this question, which is nothing but a low pass filter, a non-inverting type low pass filter, frequency response is given, and from the frequency response we can notice maximum gain in decibel is 12 dB, and x axis is again in a log scale, log of omega is equal to 3, and at that point gain is 9. So we can say this is nothing but a 3 dB point, gain has decreased by 3 dB, from 12 gain is decreasing to 9, gain is decreasing by 3 dB. So this must be a point of 3 dB frequency. Okay, this should be a point of 3 dB cutoff frequency. Now we will do 2 things here. First of all, by using maximum gain value, let me write here maximum gain 20 into log A max, this is equal to 12. Fine. Now from here if you calculate A max, you will be getting A max approximately equal to 4. Now this is a non-inverting type low pass filter, and in a non-inverting type low pass filter maximum gain will be 1 plus R2 upon R1, that is equal to 4. So if you rearrange, you will get R2 equal to 3 R1. Now in this question R2 is R and that R1 is equal to 1 kilo ohm. If you look at the circuit, this is your resistor R2 which we have to calculate, this is R2 and this is R1. Okay, so I have substituting R2 is equal to R and R1 is equal to 1k. So in this way if I obtain here resistance R, it will be equal to 3 kilo ohms. For this low pass filter R is equal to 3 kilo ohms. Then we will find the other data, that 3 dB cutoff point data, 20, it is a 10 into log 10 into log of omega c is equal to 3. Okay, this I have taken from the given frequency response. 20 into log omega c, I think 10, it is simply log into 10, log omega c, this is simply log omega c. If you look at the question, this axis is log omega c is equal to 3. So from here we will calculate omega c will be equal to 10 to the power 3, and that is 1000 radian per second, 1000 radian per second. Now in this non-inverting type low pass filter, that omega c, it depends on these RC elements. Let me call this resistor as some R3, I will name this as R3. So in this non-inverting low pass filter, cutoff frequency depends on these RC elements, and that cutoff will be 1 by R3 into C. Let me use the data here. Omega c is equal to 1 by R3 into C. From here we can calculate capacitance value, 1 divided by R3 into omega c. That R3 is given as 1000 ohms or 1 kilo ohms, and omega c is also 1000. So this calculates to 1 microfarad. For this non-inverting type low pass filter, resistor R is equal to 3 kilo ohm and capacitance should be 1 microfarad. This was, I think, a multiple choice question. So these are the correct values. Let us move to the next question. Now this question is based on Cmos inverter concept. Okay, this is nothing but a Cmos inverter. You have a P channel MOSFET and N channel MOSFET, and that gate and drain are getting shorted for both the MOSFETs. If you observe PMOS, drain shorted to gate, and for NMOS also drain shorted to gate. And we know very well that whenever drain shorted to gate, such MOSFET will be in saturation region. So we can directly tell here that in this inverter circuit both MOSFETs are in saturation region, and these MOSFETs are in series also. So we can simply equate their currents. We have done so many such questions in our regular classes, questions based on circuits where we have two MOSFETs connected in series. And I always told that whenever you get such a question, first decide operating region of the two MOSFETs and then equate currents of the two MOSFETs and proceed with the solution. So we will be using here our standard approach. MOSFETs are in series, their currents must be equal. So let us equate currents of the two MOSFETs. Drain current of NMOS is equal to drain current of PMOS, and both MOSFETs are in saturation. So we can write current through saturation formula, mu n COX upon 2 into W by L of NMOS into VGSN minus VTN whole square is equal to drain current of PMOS, that will be mu P COX divided by 2 into W by L of PMOS into Vs Gp minus mod Vtp whole square. Now in the question it is told that both MOSFETs have same value of COX. So COX term it will cancel out, that by 2 will also cancel. Mu n is given as 300, then W by L for the NMOS it is given as 1 into, if you notice, VGS for NMOS it will be simply equal to V0 itself. For N channel MOSFET VGS is equal to V0, and for P channel MOSFET Vs Gp it will be equal to 4 minus V0. Let us substitute these things. VGS for NMOS is simply V0 and threshold is 1 volt whole square is equal to, this is given as 40, and W by L for PMOS is given as 5 into Vs Gp it is 4 minus V0 minus 1 whole square. Now this equation we should bring into quadratic form. If you bring this into quadratic form, you will be getting an equation like this. It will be V0 square plus 6 V0 minus 15 is equal to 0. It is a standard approach. We equate currents of the two MOSFETs and then bring a quadratic equation into form. This equation we should solve. If you solve this equation, you will be getting two roots. I will simply write, after solving that solution, you know how to do it. Root of a quadratic minus b plus minus under root b square minus 4ac whole divided by 2 into a. That approach you follow and find out the roots. You will be getting two values, 1.898 volt and minus 7.89 volt. Okay. After solving this quadratic, we will get these two roots. Now minus 7.89 cannot be the answer, because for this CMOS inverter output should be between 0 volt and 4 volt. Output has to be between 0 and VDD. So in this way minus 7.89 I can ignore, and the correct answer should be 1.898. So for this CMOS inverter question, 1.898 volt is the correct answer. So these were three questions which I did here. There are three more questions which my dear colleague Rajkumar sir will take up. Thank you, dear students.
Thank you very much, Iftikhar sir. Very good evening, students. Let us start the remaining questions. I will try to deal. Already 3 questions has been completed by Iftikhar sir. Remaining 3 questions I will explain you. Okay. Let us see the next question. Question number 4. This is a MOSFET question, MOSFET related question. This question already came in GATE exam, okay, maybe in the year of 2014 or 2013. In workbook also, in MEDISI workbook we have practiced at the time, but recently we have removed this question. But this question most of the students have been done, I am expecting. We can do in 2 different ways this question. What he is asking is here, VA and VB both are small signal voltages, okay, they are not DC voltages, they are small signal voltages, and is asking VA by VB ratio. Whenever the person said small signal, immediately we have to go for AC analysis first. Let us write this model in AC analysis. What happens? Let us see. See the circuit one time. 2 volts he has given, input signal he has given 2K, 4K, 4 volts. First make 4 volts grounded and 2 volts grounded, because we are doing AC analysis, that is small signal analysis. Okay. Here only I will complete, otherwise it will not take much time to complete this task. So, first we will take signal VI, small signal analysis I am doing. This is just I am changing the color. So, this is MOSFET. We have 2K, here we have 4K, make this as ground. This is VA, you are telling, this is VB. We have two values. Just he is expecting VA by VB ratio is asking. Then the small signal current, if you take this as ID current, the same current ID will flow here also. So, same current is flowing in both sides. Just a small trick here. What is VA? You find out with the ID current into resistance. How much the value you can see here. VA, we can write it as minus ID times of 4K. This is VA, correct? And what is VB here is ID times of 2K. So, this is VA and VB values. Just we want to take the ratio of these two. So, VA divided by VB. If you want this answer, minus ID into 4K divided by ID into 2K. Okay, within single step we can cover this answer, cancel this one, answer will be minus 2. So, this question is very comfortable, I am expecting to the students, okay, electrical or EC, anybody can do this question who has a basic knowledge on amplifiers. The word small signal, whenever he speak, we should not talk about DC conditions, we have to just eliminate the DC conditions, immediately we will get the answer. This is one approach. If you want another way of doing this problem, you consider this as an amplifier, where DC will be grounded, consider like an amplifier. One time you neglect this output which is connected to the source, take the drain output, only drain output find out the voltage gain, that is small signal voltage gain you find out, that is the first step. When you find out VA by VI, which is a small signal voltage gain, this type of amplifier will become a common source unbypass amplifier. A common source unbypass we have practiced in the classroom, it is the gain will be minus GM into RD divided by 1 plus GM into RS, that is the first formula. And again you take VB as an output, neglect the VA output, it will become one more amplifier, that is a common drain amplifier. Common drain amplifier voltage gain value will be GM into RS divided by 1 plus GM into RS. You take that ratio, automatically you will get the same answer. Any approach is okay. Okay, this is one question, minus 2 will be the correct answer according to the memory based question I am doing it, maybe values may differ. Okay. Next question we will see, the next question, this is the next question for you, find the 3 dB frequency, find the 3 dB frequency for the given op amp circuit, and not only 3 dB frequency, I think he is asking about the type of filter also, maybe that is not added here. Some students are telling type of filter also they have asked. Really speaking, this question also came already in GATE exam. Okay, repeatedly I have seen this year 2 or 3 questions are repeated. Some questions are very good questions, like our first question has been tackled by Iftikhar sir, that is a stable multivibrator is a good question. And one more question is there at the end, I will show you, that is a MOSFET question. Some questions are thinking questions, some are very simple questions. It is also came from active filter question. Already one question has been completed, this is one more question for you. He is asking what type of filter it is. Simply to find out this filter, just we can finish off by taking some transfer function. We can finish off this one. We can understand what type of filter it is. You take these two concepts as this as some ZF you can take, this as some Z1. If you see, this is looking like a inverting amplifier, correct? If this is an inverting amplifier, you can write here inverting amplifier gain V0 by VIN, inverting amplifier gain in modulus if you take, which is a transfer function I am finding directly. It is ZF by Z1. Actually, it is gain is minus ZF by Z1 is inverting amplifier. Just magnitude wise I am solving. It is ZF by Z1. ZF is here. We will take this as some R2. We will take this as some name R1. This as C. Okay. We'll write this answer as simply minus R2 will be the ZF divided by minus, you can leave it off. Just minus, leave it off. Okay. Yeah. So it is an inverting amplifier. So V0 by Vn will be ZF by Z1. Okay, minus ZF by Z1, minus I removed. So it is minus R2 by R1 or Z1. Z1 means you have to take this combination. So it will become R1 plus 1 by SC. Okay, and you can take this as plus because we have neglected that sign. So this transfer function if you write, it looks like this, SC into R2 divided by 1 plus SC into R1. It is a simple transfer function I got. Whenever the transfer function is represented like that, you must have a good knowledge on standard transfer functions of a filter. Okay. Anybody see 1 0 1 pole like this, we call it as high pass filter, straightforward. Otherwise you have to substitute omega equal to 0, omega equal to infinity, you have to check all these things. If you have a good knowledge of transfer function techniques, easily you can tell this transfer function is in the style of S by 1 plus S tau. This is the generalized form per high pass filter technique. So this is a high pass, I recognize this circuit. So first bit is over, it is a high pass. So what is the type of filter is being understood, it is a high pass filter, and next is asking 3 dB frequency. Maybe according to the given question, memory based question, he may ask it in radians per second or frequency in Hertz, I do not know. I am solving for omega, that is radians per second. If you want to convert in F max 1 by 2 by RC, you can do it. But here what is omega here? Omega 3 dB is nothing but 1 by your time constant. Okay, what is the time constant is? In the pole function, this is your time constant. C into R1 will become the time constant here. So you can write this answer as 1 by C into R1. This will give the 3 dB frequency for that problem. So you can take it as 1 by C is 1 microfarad, C is 1 microfarad, R1 is 2000 ohms. So you can calculate this answer and you can see that one. I think according to my calculation, I got around this answer around, I got 500 radians per second. I got around 500 radians per second. So as it is a memory based question, I do not know whether they ask omega 3 dB or F 3 dB. You can convert according to that. These are the two basic questions I have been covered. Only one more question is there, which is MOSFET related question. Let us understand that final question and I will stop this and log. Okay. Next subject will be starting from that. We will see one more question related to this. So correctly you observe this question. Yeah, just 1 minute. So the next question, if you see final question, which in analog we got this data, a long channel N MOSFET channel length L is given, channel length L is given, and one more he has given is W he has given, L value and W value he has given, and electron mobility nu n and oxide capacitance, they are all the data for the MOSFET he has given. And what is the typical point here I observed is Vt here is not 1, the symbol is wrong. Vt means threshold voltage, it is 1 volt, and Vgs he has given 2 sin 2t. Here most of the people will get confused. If they give 2 volts, it is easily I can identify the MOSFET is in which region, all those things. 2 minus sin 2t has given. For that, how to approach this question, let us understand. And Vds he has given here as Vds point, just 1 minute, Vds is 1 volt, here Vds is also given as 1 volt here. What is the maximum drain to source current IDS max is asking. Let us understand this approach. Okay. First of all, Vgs how to define in the concept. First of all, how to define Vgs we will see, and in which region it will get the maximum IDS, because most of the students knows that in current saturation we will get the maximum current. That is not the meaning here. Where Vgs will be maximum value we can get, in ID current we will get the maximum current, but he has not given a DC voltage, he has given a DC plus AC voltage. So instantaneously we have to see at what voltage of Vgs your ID will be maximum. So this is something good thinking question I am expecting. Let us see in the next page, I will do it for you. There is a problem here, I think. Just 1 minute. Cut chase, huh? Just next slide is not coming here. Yeah, sorry for that, sorry for the interruption. So this is the question, now we are going to deal now this question. Okay. In the next slide we will see how to do this problem. Let us write the data first. L is given, first given data I will show you. Given data, sorry, color I will change, white is better. Given data, first we will write the L value. L value how much he has given in the problem, otherwise I will take from my page. I have with me, just 1 minute. L is 10 micrometer, okay. W he has given as 100 micrometer, okay. Nu n Cox he has given as 1 milliampere per volt square, and threshold voltage he has given as 1 volt. VGS he has given as 2 minus sin 2t volts, and VDS he has given as 1 volt. He is asking you ID max is how much. This is the data given in the question. So if I want to solve this question, first of all, at what VGS value ID will be maximum we have to check. For that, first we have to know in which region this MOSFET is working. Then how I am going to test the MOSFET. Let us see the approach. First of all, VGS how to define here. VGS, I am defining the waveform for this. You can see the DC voltage here is 2 volts, DC is 2, the sin 2t with minus 1 it is moving, so maybe it will move like this. 2 minus 1 is 1, 2 minus of minus 1 it will be 3. So I think your VGS value have the peak values like this. One is at the lower peak 1, above 3 This is the meaning of this 2 sin 2t. At what instant the VGS is getting maximum is here. VGS at this position we have maximum, but at this position VGS is coming minimum. So like this I can understand two values, VGS minimum, VGS maximum. But at what position we have to check now. That ID will be in which region it is working means, if I want to know ID should be maximum, I know that VGS should be maximum, because IDS is proportional to VGS. It may be in triode equation or it may be in current saturation, whatever may be the equation, VGS if it increases, ID will increase. So from this total sense, what are instantaneous points, at the peak point of 3 volts VGS is maximum, correct. So I can expect we'll take this position where we can find out ID max. So VGS, suppose if we take 3 volts in the concept, which is a maximum value, and VDS he has given as 1 volt in the problem, and the threshold he has given as 1 volt. This is the data we have with us. But if you get all the values, VGS I got, VT I got, and one more is VDS I got, I can check one time in which region we have to find out the maximum IDS. So VDS, if it is less than VGS minus VT, suppose this condition is satisfied with this data, you will be in you will be in linear or triode region, we can say. This condition is meant for triode region. Let us check here, 1 volt is coming less than 3 minus 1, so 1 is less than 2. So I think this condition is getting satisfied, correct. If this condition is satisfied, you can expect your MOSFET will work in triode region. So this is the way first you have to check the concept. If the MOSFET is in triode region, okay, in that you have to find out the maximum value. Maximum value we can get at the instant in which value of 3 volts. Exactly at the peak point of 3 we can find out. So this condition makes me to write your ID equation, ID max if you want, triode equation you can write, that is nu n Cox W by L into VGS max you take minus VT into VDS minus half into VDS square. You can apply the triode equation. Most of the students is having a hobby how to write the triode equation. So this is a complete triode equation where I have to substitute the maximum value to get the maximum current in that region, okay, in the triode region. So can I expect the value will be, so if you substitute this data, nu n Cox is 1 milliampere per volt square, W by L is 100 micrometers divided by 10 micrometers, it will become 10, into VGS max is 3 we got, minus threshold is 1, into VDS is 1, minus half into 1 square is 1. So this is the information for us. This total will become 10, this become 2 minus half is 1.5. So I am expecting it will be 15 milliamperes we will get. So this is a very good question, conceptual question. Most of the people will think that it is in current saturation. If it is in current saturation, straightforward you will tell the answer that it is the maximum current in current saturation. But in the given question, at what VGS value the current will be maximum. So I think we got a triode region, the current is getting maximum. But if you take this sample, this position, this area, you are getting minimum current. But this region, if you check it, it works in current saturation. According to the condition, this will work in current saturation, this total portion will work in triode. So we are expecting not below region, we are expecting above region where the maximum current we can get. I can find at 2.1, 2.2, 2.3 also, but where the ID maximum will come in triode region we have to find out. So finally I am expecting maybe in your options 15 milliamps will be there, I am expecting, because I do not have options with me. So it is a memory based question, so according to the method I solved it, okay. You can see the procedure according to that. So with this I have been completed all the 3 questions which is assigned to me. So Iftikhar sir already explained 3 questions, total 6 questions, we got the data. Thank you very much. The next subject will be proceeding on. Thank you.
Good evening everyone. I am Rohit Kumar Tripathi. So me and Naveen sir, we are going to discuss some questions of signal and system. तो ये सब मेमोरी बेस्ड क्वेश्चंस हैं, मे भी हो सकता है जो एक्चुअल डाटा होगा इससे कुछ चेंज होगा, तो जितना अपने पास अवेलेबल डेटा है उसके अकॉर्डिंग हम लोग रिप्लाई कर रहे हैं। तो फर्स्ट क्वेश्चन कुछ ऐसा है जिसमें 4 सिस्टम्स गिवन है S1, S2, S3 एंड S4, और इन चारों के लिए इनपुट है साइन ऑफ टी और सिस्टम आउटपुट भी गिवन है, और देख करके बताना है कि आउट ऑफ दिस 4 सिस्टम्स विच वन इज नॉट डेफिनेटली LTI। ठीक है, इसमें कौन LTI नहीं है। और एक पॉइंट ध्यान देने वाली बात है कि ये MSQ क्वेश्चन है, मतलब मोर देन वन ऑप्शन करेक्ट हो सकता है। तो देखो, इसे ट्रिकी वे में सॉल्व करने का एक तरीका मैं बताता हूँ। सबसे पहले अगर सिस्टम LTI है तो LTI सिस्टम इनपुट में अगर साइनोसॉइडल टर्म है तो उसके फ्रीक्वेंसी को चेंज नहीं करता है। सो LTI सिस्टम डज नॉट चेंज फ्रीक्वेंसी ऑफ साइनोसॉइडल सिग्नल। तो LTI सिस्टम साइनोसॉइडल सिग्नल के फ्रीक्वेंसी को चेंज नहीं करता है। ठीक है, पहले तो ये जो टर्म गिवन है आप इसे इस फॉर्म में भी लिख सकते हैं, माइनस साइन टी। ठीक है, ओके, इसे इसी फॉर्म में रहने देता हूँ। और ये जो फोर्थ टर्म है इसे आप लिख सकते हैं 1 माइनस कॉस 2t डिवाइडेड बाई 2। ओके, क्लियर है। अब थोड़ा ध्यान से देखो मैंने क्या बोला था कि LTI सिस्टम इनपुट के साइनोसॉइडल सिग्नल के फ्रीक्वेंसी को चेंज नहीं करता है। तो यहाँ साइनोसाइड की फ्रीक्वेंसी कितनी है, 1 रेडियन पर सेकेंड। साइन ओमेगा नॉट टी में ओमेगा नॉट कितना है, 1 रेडियन पर सेकेंड, क्योंकि ये साइन टी है। अच्छा, यहाँ जो माइनस साइन टी है इसमें भी फ्रीक्वेंसी कितनी है, 1 रेडियन पर सेकेंड। तो यहाँ साइनोसाइड के फ्रीक्वेंसी में चेंज हुआ क्या, नहीं हुआ। इट मीन्स ये LTI हो सकता है क्योंकि यहाँ पर साइनोसाइड के फ्रीक्वेंसी में चेंज नहीं हुआ। ओके, सो दिस सिस्टम मे बी LTI, दिस सिस्टम मे बी LTI। रीज़न मैंने क्या बताया कि साइनोसाइड के फ्रीक्वेंसी में चेंज नहीं होगा अगर सिस्टम LTI है, और अगर LTI सिस्टम के इनपुट में जो साइनोसाइड है उसकी फ्रीक्वेंसी चेंज हो गई तो सिस्टम गारंटीड नॉन LTI है। ओके, so now what is second system? Second system input is sin t and output is sin of t plus 1. Now if you look out what is the frequency of input signal, 1 radian per second. Now what is the frequency of output signal, also 1 radian per second. So there will not be any change in the frequency of input and output. It means this system is guaranteed LTI. So this system is again LTI. Now what about the third system? If you will observe, then what is the frequency of input signal, 1 radian per second. Now what is the frequency of output signal, 2 radian per second. Since LTI system does not provide change in frequency of the input signal, and here output frequency is different than input frequency, that is why second system is non-LTI. Now what about the fourth system? Now what is the frequency of input, 1 radian per second. Now look at this component cos 2t. Now what is the frequency in the cos 2t term, 2 radian per second. So again here frequency change is taking place from input to output. Since there is a frequency change from input to output, it means system 4 is definitely non-LTI. So, the systems which are definitely non-LTI, those two systems are S3 and S4. So, S3 is written in option C and S4 is written in option D. It means answer for this question are option C and option D, both of these. So, answer for these questions are option C and option D. Now, let us solve next question. So, let us see what is the next question. So, next question is related to discrete Fourier transform. So, x of n is given, and for this x of n, discrete Fourier transform is x of k. Okay. Now, if you look out how many samples in x of n are given. So, number of samples in x of n are 8. It means what is the value of capital N? Value of capital N is 8. It is also given in the question 8-point signal. Now, for this 8-point signal, what is 8-point DFT x of k? Now, what is the second part of the question? Second part is like this. There is another signal y of n, and y of n, for y of n, what is DFT y of k? So, here one correction, this is y of k, this is not y of n. Okay. So, I am performing correction here. So, for y of n, DFT is y of k, and what is the relationship between yk and x of n? Yk is DFT of x of n. It means a question is saying that if you will perform 2 times DFT on x of n, then resultant DFT will be what? Y of k. And what we have to do? We have to calculate value of y of n at n equal to 0. So, this term is nothing but value of y of n at n equal to 0. So, how should we proceed here? We can do in this way. What this term is representing, we have to use property of duality. So, what property we are going to use? Duality. So, what happens in duality? In duality, if you will apply 2 times DFT on a signal. So, if you will apply how many times DFT on a signal? 2 times DFT on a signal. Then what will be the resultant DFT? Resultant DFT will be like this, n into x of minus k. Okay. And question is saying that 2 times DFT of x of n is equal to y of k. It means n into x of minus k, this term is small x. Okay. So, it is equal to y of k. So, till now what we have seen that there is a relationship between yk and small x function of minus k. So, what is the relationship? Yk is equal to n into small x function of minus k. Now, if you will apply any operation in a DFT either on the time domain signal or the DFT function, then you have to apply mod n operation. So, modulus operation you have to apply, and according to this you will write down in this way small x in bracket n minus k. Now, what is the value of n here? Value of n is how much? 8. Now, it is also given in the question what are the samples of x of n. Samples of x of n are already given. So, we have to write down samples of y of k. So, how we are going to write? We are going to write in this way. What is the value of capital N? 8. Now, we have to write down samples of small x in bracket n minus k. Or in other words, there is a trick. If in a DFT, if you want to fold any function, like we have to fold samples of x of n, because if we will fold samples of x of n, then it will be equal to samples of x of minus k. So, what we have to do? We have to fold samples of x of n, and there is a trick. in this trick what you have to do, you have to make this sample as it is. It means you are not going to touch this sample, and remaining samples you are going to fold. So you don't have to touch this sample, but remaining samples you have to fold, and in this way the resultant function will be nothing but time folding of this x of n in case of n point signal. Okay. So what we are going to do, we will write down this sample as it is, and we will fold remaining samples. If you will fold remaining samples, then sequence will look like same again. So this will be the resultant y of k. Now we have to write samples of y of k. So what we are going to do, now we will multiply these many samples with constant value 8. So 8 into 2 will be how much? 16. 0 0 0 8 0 0 0. Okay. So these are the samples of y of k. Okay. Now what we have to calculate? We have to calculate value of yn at n equal to 0. So what we are going to do, we will write inverse DFT formula. So suppose we have to calculate y of n from y of k, then what we are going to use inverse DFT formula, which is like this: 1 by n summation yk e to power j 2 pi upon n into kn. Now what is the range of k? Range of k will be 0 to n minus 1. Now what we have to calculate? We have to calculate yn at n equal to 0. So what we are going to do? We will put n equal to 0 in this relationship. So value of yn at n equal to 0, it will be equal to 1 by n into summation yk. Okay, because if you will put n equal to 0, then e to power 0 will be how much? 1. And what is the range? Range of k will be 0 to n minus 1. Now value of capital N is how much? 8. So summation 0 to n minus 1, which will be 7 into y of k. Okay. So y0 will be equal to 1 by 8 into summation of samples of yk. Now these are the samples of yk. We have to add the samples. So summation will be how much? 16 plus 8. So summation will be how much? 16 plus 8. 16 plus 8 is how much? 24. So 24 by 8. So answer is how much? 3. So for this question, what is the value of yn at n equal to 0? 3. Okay. Now there are two more questions in DFT, and those questions will be discussed by Naveen sir.
Thank you, Rohit sir. Hello everyone. So we will see about the next memory based questions from signals and system. So coming to the next question. So question number, the Fourier transform x of j omega of x of t is equal to t by 1 plus t square of whole square he was asking. So for this we can use the property that is called as the duality property, you can use from the Fourier transform. So if you see the duality property, then so talking about the solution for that. So given that x of t value is equal to that of t divided by 1 plus t square of whole square. So we can see the formula, the general formula we studied, e to the power of t into e to the power of minus a of mod t. The Fourier transform for this is equal to minus j 4a omega divided by a square plus omega square whole square. We got this relation of the Fourier transform, and from this we are applying the duality property. So on this one, once we apply the duality property, we can get the relation that is so we replace omega value with t and then we can replace our t with minus omega. So replacing the omega value with the t, that is equal to minus j4 a into t whole divided by the value is equal to a square plus t square of whole square. And for this, if you apply the duality, we get that 2 pi, because of omega we have the 2 pi value, and it is replacing our t value with minus omega and e to the power of minus a, and again the t is replacing with minus omega. So after that we can see the required form by substituting the value of a is equal to 1. Why? Because means in the question it was asking t upon 1 plus t square of whole square. So in the place of here a, if we replace with 1, then we get the 1 square, which is equal to 1 plus t square of whole square, and also here also we are replacing the numerator part with a is equal to 1. Then we can see by replacing a is equal to 1, we get minus j 4 t whole divided by the value is equal to 1 plus t square of whole square, and that is equal to that of minus 2 pi omega e to the power of minus 1. So mod of minus omega will become as omega, that is mod of omega. So we are replacing a value with 1 here also. So after that, if you write in the required form, if you just write that in the required form, so it is equal to that of t divided by 1 plus t square of whole square. Just he was asking the Fourier transform for this value, t divided by 1 plus t square of whole square, and for this value we are getting minus 2 pi upon the value is equal to minus j4. I am taking this minus j4 to the other side, so therefore we can have omega into e power minus of mod omega is obtained. So now we can cancel out this minus sign and it is 2. The required answer is nothing but n. So pi by j into 2 omega e to the power of minus mod of omega, that is equal to t divided by 1 plus t square of whole square. Fourier transform is this value. If you check the options, you can find out from the option. So that is equal to that of pi by 2j omega e to the power of minus mod omega is the answer we are having. So option D is the answer we have. So if you just check it, the same thing we obtained here, it is that is equal to pi by 2j omega e to the power of minus mod of omega. So this is the simple question which we see already in the classroom notes also. So coming to the next question, let x1 of t is equal to e power minus 2t into u of t and x2 of t is equal to u of t minus u of t minus 2, where u of t denotes a unit step function. Let y of t is equal to convolution of x1 of t and x2 of t, then limit t tends to infinite, y of t value is equal to how much? So if you see here, we can take the given values of x1 of t, solution for this one. So taking the x1 of t is equal to e power minus 2t into u of t is the value we are having. And if you talk about the x2 of t, that is also given in the question, that is equal to u of t minus u of t minus 2. Now we are applying the Laplace transform for this one. So apply Laplace transform. So once we apply the Laplace transform, so x1 of s is equal to, so 1 by s plus 2 is the value we are having, and x2 of s, by applying the Laplace transform, u of t Laplace transform is 1 by s and u of t minus 2 is e power minus 2s upon s is the value we are having. So here asking that y of t is the convolution of x1 of t and x2 of t, that is equal to that of y of t is nothing but an x1 of t convolved with x2 of t. So once again the convolution in time domain become as multiplication in the another domain. So therefore we are applying the Laplace. So once we apply the Laplace, so the convolution changes into the multiplication, where the calculation become quite easier. So we can apply the Laplace transform so that we can get y of s. So y of s is obtained, so that is equal to that of y of s is equal to x1 of s. Already I told to you convolution become as multiplication. So x1 of s into x2 of s. So x1 of s is already obtained as 1 by s plus 2 into x2 of s. x2 of s is equal to 1 by e to the power of minus 2s whole upon s, and that is the value of y of s we are having. In the question he was asking the value at t is equal to infinite in y of t. That means when you write like this, y of t limit t tends to infinite, so y of t that is equal to y of infinite, then limit s tends to 0 s into y of s. Already y of s is defined by ourselves by taking the Laplace transform. So convolution become as a multiplication, then that is equal to that of limit s tends to 0 s into, so y of s that is 1 minus e to the power of minus 2s upon s into s plus 2. S and s get cancelled to each other, and we substitute the value is equal to that of 0. So s is equal to 0, the value is equal to, total value is 0. Why? Because means e power 0 is 1, so 1 minus 1 is become equal to 0. So this question is also simply obtained from the test series, and I think every student will solve this question, right? The next subject will follows. Thank you.
Yeah. Good evening, students. This is Naresh Reddy, and I'm going to deal here the communication systems questions. And these questions here, what you see, these questions are based on the inputs from the students, and these are purely memory-based questions. So almost 7 to 8 questions came from communication systems. I came to know that, but we received the proper data for 4 questions, and I'm going to discuss those 4 questions now. Okay, and once the actual paper will released, and the MEDISI will release the solutions for all the questions. Okay, now I will discuss these questions which are purely memory based. Okay, and if you see this first question here, okay, yes, this is about a channel diagram is given here, and for this channel diagram, this the inputs will be ABC, the possible source inputs will be, and the received symbols are ABC is given here. And what you see here, these are the transition probabilities, or I can say these are crossover probabilities. These are simply channel probabilities are given. And here we have to find the value of alpha for which the channel capacity will be maximum, and how to find the channel capacity. Okay, the channel capacity, yes, first we will find out mutual information. I am going to find out Ix comma y. Ix comma y is equals to, this is Hy minus Hy by x. Okay, and the max of this mutual information will give you the channel capacity. Okay, so to find this Hy and Hy by x, okay, first we need the corresponding probability matrices. So first we will see the corresponding probability matrices, and from those probability matrices we can easily find out these entropies. We can find out. Okay, now, so to find Hy by x, if you see the formula for Hy by x here, so here for convenience in notations, okay, I will take here, this is the source symbols are x1, x2, x3, I am denoting with. The receiver symbols will be y1, y2, y3, I am denoting with. Okay, then yes, the formula will be Hy by x, the formula will be, this is summation, this is I is equals to 1, 2, 3 and summation j is equals to 1, 2, 3. If you write minus here, then this is p xi comma yj, this is log p yj by xa xi base 2. Okay, so it will be, yes. Now, so to find this okay, to find this Hy by x, we need p x comma y matrix we need, and p y by x matrix also we need. We need these two matrices we need. So first I will write p y by x matrix. I am going to write, this is, yeah, yes, p y by x matrix, the conditional probability matrix I am going to write. Okay, first I am mapping like this, x1, x2, x3 and y1, y2, y3. Okay, now if you use the corresponding, what the corresponding probabilities, if you see, yes, so what is the probability of transmitted x1, okay, received as y1, 1 minus alpha, this is, and x1 received as y2, this is alpha, and x1 received as y3 will be 0, and x2 received as y1 will be 0, and x2 received as y2 alpha, and x2 received as y3 will be 1 minus alpha. Then x3 received as y1, so this is alpha, the probability will be, and x3 received as y2 0, and x3 received as y3 will be 1 minus alpha. Okay, this is p y by x matrix we got. Yes, in p y by x matrix, the sum of the elements of each row of course will be equals to 1. Okay, now fine. Now I need p x comma y matrix, I need, this is p x comma y matrix will be, this is p x diagonal into p y by x. Okay, now the default of the source probabilities, okay, the default source probabilities I am assuming 1 by 3. If the source probability is not given, then you can take the default of equal probability you can take. Okay, so for convenience in analysis, okay, here the assumption is the source probabilities are equal here, so 1 by 3 each. Then what is p x comma y will be equals to, this is, so you have to multiply p y by x with this px diagonal, you have to multiply. So multiplying with px diagonal means it is simply row by row multiplication only. First row elements we have to multiply with px1, second row elements with px2, third row elements with px3, and of course the source probabilities are equal, it is our assumption. So it will be now 1 minus alpha by 3, just multiply first row elements with px1 means 1 by 3, you have to multiply with alpha by 3 and 0. Next, yeah, next 0, second row you have to multiply with the px2 means 1 by 3 only, so it is 1 minus alpha by 3. Next px3, okay, this is, so you have to, yes, so this is alpha by 3 and 0 and 1 minus alpha by 3. This is, so it is Px comma y matrix you got. So multiply each of the roots with Px1, Px2 and Px3 respectively, and this is Px comma y we got. Now yes, we have to find out h y by x, we have to find out, okay. And what is the formula? As I said, this is summation I is equals to 1 2 3 and j is equals to 1 2 3. This is Pxi comma yj, this is log P yj by xi, and base 2 of course will be there. And if you expand this summation, what the elements you can get is, so this Pxi comma yj, these are the elements corresponding to Px comma y matrix, okay, and Pyj by xi, so these probabilities corresponding to, okay, this matrix Py by x, okay. So now if you do this multiplication, yes, then what you can expect is, this is minus, so Px comma y log Py by x, and if you do that multiplication, you can expect 1 minus alpha by 3 log 1 minus alpha plus alpha by 3 log alpha plus alpha by 3 log alpha, like that, okay. So by expanding the summation, what you can expect is, yes, so by doing this complete of analysis, maybe, yeah, I will write 1 minus alpha by 3, okay, 1 minus alpha by 3 and log 1 minus alpha, this is, of course base 2 will be there, okay, plus, and alpha by 3 and this is log alpha, okay, plus alpha by 3, this is, and log alpha by 3 log alpha, this is log alpha, of course base 2 will be there everywhere, plus, and this is 1 minus alpha by 3 and this is log 1 minus alpha, you will get, I think, yes, log 1 minus alpha, plus alpha by 3, this is alpha by 3, this is, yeah, alpha by 3 log alpha, this is, of course base 2 will be there, plus 1 minus alpha by 3 log base 2, this is 1 minus alpha by 3 log 1 minus alpha, log 1 minus alpha, this is, okay. And if you simplify this, yes, so h y by x, if you simplify this, you will come to know this is alpha log alpha plus 1 minus alpha log 1 minus alpha, this is what you will get after simplification. Then I x comma y, mutual information we need to find out, so this is hy minus hy by x, okay, and after substitution, this I x comma y is equals to, this is hy plus, so if you see hy minus x, minus is there and minus minus will become plus, alpha log alpha base 2 plus 1 minus alpha log 1 minus alpha base 2. Now yes, we have to find the channel capacity. Channel capacity means it is max of I x comma y will give you the channel capacity, and what this will be is, max of I x comma y means what is the mutual information with the max of h y, okay. So with the max of h y, what is I x comma y, so that will be channel capacity for us, okay. So max of I x comma y is nothing but what is mutual information with maximum possible h y, and what is the maximum possible h y? Here 3 possible symbols at the receiver side, okay, y1, y2, y3. So 3 possible symbols at the receiver side, then what is the maximum possible entropy for the receiver is log 3 base 2. Okay, so this is actually max of hy plus alpha log alpha plus 1 minus alpha log 1 minus alpha base 2. Okay, so this will be, so max of hy will be log 3 base 2, okay, plus alpha log alpha base 2 plus 1 minus alpha log 1 minus alpha base 2. Okay, now what is the question here is, what is the alpha value for which this channel capacity will become maximum? We have to find out for which alpha value the channel capacity will be maximum. And if you plot this, this is, maybe most of you done mistake here. Okay, so if you see, if you plot this, I am just plotting this alpha log alpha base 2 plus 1 minus alpha log 1 minus alpha base 2. So if you plot this, okay, where alpha I am taking from 0 to 1, this is, yes, so in the range of alpha 0 to 1. If you plot, okay, this is going to be like this, this is, you will get like this. So if you plot this portion alpha log alpha plus 1 minus alpha log 1 minus alpha, if you plot this where alpha I am taking from 0 to 1, so at alpha is equals 0.5, so you will get this is minus 1, this is minus 1. So at alpha is equals 0.5, this is a negative maximum. Okay, so minus 1 means it is a negative maximum. It is a negative maximum means the channel capacity is going to be minimum. So at alpha is equals 0.5, this quantity will give you negative maximum. This quantity giving negative maximum means the channel capacity will become minimum. The channel capacity will be minimum at alpha is equals 0.5. And when channel capacity is maximum, this channel capacity is maximum when alpha is equal 0 and alpha equals to 1. Yes, when alpha is equal 0 and alpha equals to 1, and this will be 0 here. This quantity will be 0 when alpha is equal 0, alpha is equals to 1. This quantity is 0 means then channel capacity will be maximum. Except this alpha 0 and alpha 1, if you take any other alpha value, then this quantity is giving negative value. You can say negative value. Then channel capacity is going to be, okay, low value you are going to get. So here the channel capacity will be maximum at alpha 0 and alpha is 1. Okay, so C here is maximum at alpha is equal 0 and 1. And in the question clearly given that alpha taking the values in the range of 0.25 comma 1. When alpha takes the values in the range of 0.25 to 1, then for which alpha value CS is maximum, I can say CS maximum at alpha equals to 1, I can say. So alpha is equals to 1 will be the answer. And even let me clarify something, what that is. Here the channel capacity, okay, the expression we got log 3 base 2 plus alpha log alpha plus 1 minus alpha log 1 minus alpha base 2. Okay, and we have to see for which alpha value the channel capacity maximum we have to find out. So for this we will do differentiation, this is with respect to alpha, and we make it to 0. Okay, so if you do the differentiation of this, so for which alpha value channel capacity is maximum, to see that we do differentiation with respect to alpha, we make it to 0. Then we do differentiation, this is what is the differentiation of this alpha, so log alpha differentiation 1 by alpha, this is, okay, plus log alpha base 2, this is, okay, and what is the differentiation of alpha? 1 plus, okay, uv, what is the differentiation? U differentiation of v plus v differentiation of u. So it is 1 minus alpha, and what is the differentiation of log 1 minus alpha? This is 1 by, this is 1 minus alpha, and what is the differentiation of 1 minus alpha? This is minus 1 plus, this is log 1 minus alpha, okay, into, what is the differentiation of this? The differentiation of this is minus 1. differentiation of 1 minus alpha is minus 1, and if you do this it comes to be, yes, so this is so alpha into 1 by alpha 1, and this is this will be cancelled, so it is 1 minus 1, both will be cancelled here, and we left with here, so we left with log alpha base 2, it is minus log 1 minus alpha base 2 is equal 0. Okay, so here this will be, yeah, so this is log alpha base 2 is equals to log 1 minus alpha base 2. Okay, so I can say here alpha equals 1 minus alpha and alpha is equals what here 1 by 2. But here you have to understand one thing, at this alpha equals 1 by 2, this channel capacity can be minimum, can be maximum also. So if you do differentiation of this with respect to alpha and make it to 0, so what the alpha you got at this alpha, this C can be maximum, can be minimum. Now let's check this. At this C value, at this alpha value 1 by 2, this channel capacity minimum will give you minimum value or maximum value. We will see that. So for that you have to do the double differentiation. This is, yes, this is d square C by d alpha square. Okay. If you do differentiation one time, this is the quantity what we got, and if you do double differentiation of this with respect to alpha, then what you are going to get, log alpha means 1 by alpha plus this is, okay, it is 1 by 1 minus alpha, this is, okay, and into this is minus 1. Okay, this is yeah, this is minus is there. So this is minus log 1 minus alpha 1 by 1 minus alpha, and differentiation of this is minus 1, and it comes to be 1 by alpha plus 1 by 1 minus alpha. This is, it is what you will get, and at alpha equals to 1 by 2, if you substitute alpha is 1 by 2 here, then d square C by d alpha square you will get greater than 0. Yes, if you substitute alpha is 1 by 2 here, then this quantity will be definitely greater than 0 you will get. This quantity is 4, means greater than 0. So at alpha 1 by 2, this double differentiation greater than 0 means at this alpha value the channel capacity will give you minimum value actually. So at this alpha equals to 1 by 2, okay, this channel capacity is going to be minimum. This is what I said actually. Okay, at alpha equals 1 by 2, this quantity will give you maximum negative value, then channel capacity will be minimum, it's going to be. That's what we got. So for which alpha value the channel capacity maximum is at alpha is equal 0 and alpha equals to 1, and based on the given range of alpha values, okay, then I can say I will go with the answer alpha equals to 1. Okay, alpha equals 1 will be the correct answer for this, and we'll see the next question. Yes. Here the transfer function of a system is given, and here two statements are given. So this system corresponding to a purely a delay system for the input applied between frequency range from minus alpha to alpha. So where the input frequency range is minus alpha to alpha, okay, for this input frequency range this system will act as a delay system. Okay, that is one statement. The another statement is the relation between input and output power spectral density, that is Sx of f equals to Sy of f, input PST equals to output PST, okay, where the input frequency range is from where to where, minus alpha to alpha. Okay. Now let's check which of the statements will be correct and which statement will be incorrect. Yes, if you see here, so I am taking this is xt, it is the input, it is applied to a system, and output is yt. Okay, and what is the transfer function of the system? Impulse response is ht, and the transfer function of course will be hf for this given system. Okay. So when I can say the given system is a delay system is provided the relation between input and output is like this. If y of t is equals to x of t minus td, if the relation between input and output is something like this, then I can say this system is working as a delay system. Okay, and for this delay system, what is the transfer function we can expect? What is the transfer function we can expect is, this is, if you find the Fourier transformation on both sides, so yf is equals to e power minus j omega td, this is xf, this is, okay. if you apply time delay property, then what is the Fourier transformation of this is e power minus j omega td xf. Omega means you can write 2 pi f also you can write. Then what is the transfer function hf is equals to yf by xf. So yf by xf is e power minus j omega td. So it is the transfer function of a delay system. Okay, the delay system transfer function is going to be like this, e power minus j omega td. But if you observe the given question, the transfer function is given like this, hf purely given as constant. Okay, actually for delay system, the magnitude response of delay system will become 1 actually, this mod hf. So if you find the magnitude of this, you will get 1. So for the delay system, the magnitude response will be 1. Okay, but the transfer function hf will be e power minus j omega td. Okay, so here this, yeah, this given system, what you see, this is not a delay system. Okay, for delay system, as I said, transfer function should be in the form of e power minus j omega td, but the transfer function is purely given as constant here. So this is not, I can say, a delay system. So statement 1 of course will be incorrect here. This is okay. S1 will be incorrect. Then what about statement 2? It is statement 2 actually. This is S2. The relation between input and output power spectral density Sxf is equals to Syf. So let's check the validity of this. Okay. Here it is clearly given that where the input frequency range is from minus alpha to alpha, xt, what is the frequency range? Okay. It is a frequency range of the input given. This is frequency range of xt, minus alpha to alpha is given. Okay. Now fine, output PST is equals to, this is, I have to relate output PST with input PST. Yes, output PST is equals to input PST into mod HF square. This is okay, and mod HF square is of course 1 only. Okay, yes, if you see this, so HF here, this is, and mod HF is also 1 only, and even if you square this, you will get 1 only. So this mod HF square is same as HF only. Okay, so mod HF square is same as HF here. This is, so it is same as mod HF square. So it is 1 where the frequency range is minus alpha to alpha. So here I can write, yes, this output PST equals to input PST. Okay, in the frequency range from where to where? Minus alpha to, this is, yes, less than or equals to alpha, less than or equals to, okay, less than or equals to alpha, f, where f is in between minus alpha and alpha. Yes, when f is in between minus alpha and alpha, then mod HF square equals to 1, mod HF square equals to 1. Okay. Yes, of course, in this frequency range, output PST equals input PST only, because what is the frequency range of input? The frequency range of input is given minus alpha to alpha. That is the frequency range of input. Okay. So yes, we got here the output PST is equals to input PST in that respect to frequency range. So output PST equals to input PST. So according to the given data here, S2 seems to be correct only. Okay. If the input frequency range also from minus alpha to alpha, okay, if you take this statement into consideration, so we have to check the validity of this once we get the complete question paper. We have to see what exactly the terminology he used in the question. Okay, so here based on the data given here, if the input frequency range is minus alpha to alpha, okay, and the transfer function is also defined in the interval minus alpha to alpha, then I can say yes, of course, the output PST equals to input PST, I can say. Okay, in that respective frequency range minus alpha to alpha. So based on the data given here, S1 is incorrect and S2 is correct, I can say. So this is B here looks to be correct here. Okay, I am saying in this frequency range. Okay, here the input frequency range is given minus alpha to alpha. I am saying in this frequency range, yes, output PST equals to input PST. But I have to check the validity of this once the complete question paper comes. So we have to see the exact terminology what he is used in the paper. So based on that, the answer can be changed. But here, according to the given data here, in this frequency range, yes, output PST equals input PST. So S1 is incorrect and S2 will be correct here. Okay, and if you see the next question, yes, So this is about pre-emphasis and de-emphasis here. Okay. So here the transfer function of a pre-emphasis system is given here. This is okay, and omega naught value also given 10 power 4 radians per second. And here he given here a low pass filter, RC low pass filter, and this RC low pass filter is used as a de-emphasis filter. Okay. So if this is used as a de-emphasis filter, and what should be the proper RNC values will be, we have to find out. Okay. Now here, yes. So for pre-emphasis, the transfer function of pre-emphasis and de-emphasis, if you see, they are inversely related to each other. Okay. So HP of f is equals to 1 by h dE of f here I can write. Okay. Or in omega domain I can write, of course, h dE of omega is equals to inverse of what you see for de-emphasis. Okay. Now and even I can relate like this. So here j terms are given in the transfer function. Okay. So for simplification and okay, for convenience in analysis, so if you see mod HPE of this is so actually speaking, this is the relation between okay, the transfer functions of pre-emphasis system and de-emphasis system. This is the relation actually, because this pre-emphasis and de-emphasis, if you recall what we studied in the classroom, okay, so this pre-emphasis and de-emphasis systems actually use it to improve the power levels of the applied message signal. Okay. So whenever you are dealing with the powers, okay, then output PST is equals to, you can write output PST is equals to input PST into mod h omega square. Okay. Here. So if you recall the pre-emphasis and de-emphasis, if you see this is the power spectral density of the message signal if you take. Okay. So we have to improve the power levels of the high frequency components. Okay. So to satisfy this requirement, okay, for the we have to deal with this mod h omega square is what we have to deal with, because output PST is equals to input PST into mod h omega square. So here so for a pre-emphasis system, that is given as HP of omega, and de-emphasis system, the transfer function is given as HDE of omega is given, and this is the relation to be satisfied. Okay. So the de-emphasis system should be inverse to the pre-emphasis system. Okay. So in satisfying this, what R and C values should be, we have to find out. So here what is this HPE of omega, what is given? 1 plus j omega by omega naught. So this is, yes, h PE of omega is equals to 1 plus j omega by omega naught. Okay, where omega naught value of course given as 10 power 4 radians per second is given. And if you see the magnitude response of this is under root of 1 plus omega by omega naught square, this is okay. And if you see mod HPE of omega square, this is 1 plus omega by omega naught square. Okay. Then what about the transfer function of de-emphasis system? So it is used as a de-emphasis system, the low pass filter. And what is the transfer function of RC low pass filter? The transfer function of RC low pass filter will be 1 by 1 plus j omega RC. This is 1 by 1 plus j omega RC. And if you see what is mod HDE of omega, okay, this is 1 by under root of 1 plus omega RC square, this is okay. And I need okay mod HT of omega square, if you see it is 1 by 1 plus okay, this is no this is actually yeah, it is omega RC square, this is okay, magnitude, and this will be omega RC square, this is. So if you square this under root will be cancelled, and this is what you will see. And what is the relation to be satisfied? HPE of omega square, this is should be equals to inverse of H dE of omega square. Okay, so from this, what is mod HPE of omega square we got? 1 plus omega by omega naught square. Now this is 1 plus omega by omega naught square equals to, and the inverse of this, what is the inverse of this? This is mod HD of omega square, and if you see the inverse of this, this is 1 plus omega RC square. This is, then here 1 will be cancelled here, this is, and this omega square also will be cancelled. Then so what you will get is, yes, 1 by omega naught square is equals to RC square. Okay, then I can write this 1 by omega naught is RC. Okay, omega naught is given 10 power 4, then RC is equals to 10 power minus 4. Omega naught is 10 power 4, so 1 by omega naught will be 10 power minus 4. So this from the given options you have to check okay, which of the given options satisfies this. RC should be equal to 10 power minus 4, and if you observe the given options, yes, RC should be 10 power minus 4. So here option A here will satisfies that. So 1 kilo ohm and 0.1 microfarad. So if you see R into C here, R is equals to 10 power 3, 1 kilo ohm, and C will be 0.1 microfarad, 0.1 into 10 power minus 6. So it will be equals to 10 power minus 4 only. Okay, so RC should be 10 power minus 4. So here option A will be correct. Okay, so the remaining question of communication systems will be taken by Naveen sir. Okay, yeah.
Thank you, Naresh sir. So these are the memory based questions for communication systems. So we see about the next question. So a symbol stream contains alternate QPSK and 16 QAM symbol. If the symbols for this stream are transmitted at the rate of 1 mega symbols per second, the data rate is dash for megabits per second he was asking. So numerical question it is. If you see the solution for this question, so first thing is, we know about the baud rate. Baud rate is given as bit rate upon n, which is also written as log m of base 2. And if you observe that here, the baud rate was going to given as 1 mega symbols per second is given. That's given in the question. Asking to find out the data rate. That means the bit rate. That's megabits per second he was asking. So if you see about the first method, that is called QPSK, the quadrature phase shift keying technique. In this, the value of n is equal to 2 and the value of m is equal to 4. And by substituting this, we will get the relation such that your bit rate is equal to that of, in place of m, I am substituting 4. That is equal to that of log 4 of base 2 into baud rate. So what are the given baud rate I am substituting here, so that you will get the required bit rate for the modulation scheme of QPSK. So if you find out the same thing by substituting the values and doing the calculation, the resultant output value we are getting for this one is, that is equal to that of 2 Mbps. So 2 Mbps is the value we are having for the bit rate of QPSK modulation system. The same procedure I can repeat it for the next one, that is called as QAM, which is given as 16 QAM is specified in the question. If you just observe that in the given question, it is given as 16 QAM. So what he was asking about the data rate for that one. So if you talk about the 16 QAM, you can find out that the value of n is equal to 4, that is 4 bits can be transmitted, and the number of output combinations that we are getting for 16 QAM is equal to, m is equal to 16. Then you can find out such that, once again substituting in the formula, the bit rate is equal to that of, you can write n also, that is equal to log 16 of base 2 into the baud rate. So what are the baud rate? It is given is equal to 1, then log 16 of base 2 is equal to 4, the total value is equal to 4 Mbps is obtained. So this is alternately we are transmitting. So alternately means 2 Mbps, and after that you can send the 4 Mbps like this. So what the data rate we are having? The combination of the complete data rate that we can have is nothing but the average data rate of these two modulation schemes we can consider. That is equal to that of 2 Mbps plus 4 Mbps upon value is equal to 2. The net resultant value is equal to that of 3 Mbps is the value we are having. So this is the question we are having. So even though what are the data obtained for us is completely member based questions. The students have shared some questions to us, and we provide the solutions for those questions. Okay. So thank you. The next subject will be followed.
Hello everyone, welcome to the GATE 2022 solution EMT subject for electronics and telecommunication. So we have received around 4 to 5 questions on EMT, but the datas were not appropriate, or some options were not actually appropriate, so it was a vague kind of thing. So we are not going to discuss those kind of incomplete questions. We will discuss those questions whose data is basically we have received correctly. तो उस हिसाब से हमारे पास सिर्फ एक क्वेश्चन है जिसका डेटा एग्जैक्टली करेक्ट है, ठीक है, तो उस क्वेश्चन को हम लोग डिस्कस कर लेते हैं. सो दिस क्वेश्चन वाज बेसिकली फ्रॉम द गॉस लॉ, बेसिक कॉन्सेप्ट ऑफ द गॉस लॉ, राइट, सो दैट वी हैव डिस्कस्ड इन द क्लास, राइट. तो देखिए इसको सॉल्यूशन कैसे करेंगे, राइट. एक और क्वेश्चन जो आया था यूनिफॉर्म प्लेन वेव्स के ऊपर भी हमने सुना है कि क्वेश्चन आया हुआ है, एंड वी हैव आल्सो हर्ड दैट सम पैरेलल प्लेट वेवगाइड पे भी क्वेश्चन आया हुआ है. तो इस तरीके से वी हैव हर्ड, वी हैव नॉट exactly receive the exact data. तो उस चीज हम लोग डिस्कस नहीं करेंगे. जब ये गेट रिलीज कर देगा क्वेश्चन, देन वी विल गो फॉर द डिटेल सॉल्यूशन विच विल बी अपलोडेड ऑन द वेबसाइट, राइट. तो चलिए फिलहाल इस क्वेश्चन को देखते हैं. क्वेश्चन जो है एक डी वेक्टर है, दैट इज इलेक्ट्रिक फ्लक्स डेंसिटी, जो ये आपका वेक्टर के फॉर्म में दे रखा है. आपसे पूछा जा रहा है व्हाट इज द चार्ज इनक्लोज्ड इन द क्यूब ऑफ साइड प्लस माइनस 0.5 सेंटर्ड एट ओरिजिन, राइट. तो हमें पता है कि चार्ज इनक्लोज्ड ये क्या होता है, इट इज इक्वल टू क्लोज वॉल्यूम इंटीग्रल रो वी इंटू डी वी. वट इज रो वी? रो वी जो होता है इट इज डेल डॉट डी इंटू डी वी, है ना. तो यहाँ पे आप देखोगे, सो इफ यू सी डेल डॉट डी, तो इसको अगर आप डेल डॉट डी इसका डाइवर्जेंस निकालोगे इस डी वेक्टर का, यू आर गोइंग टू गेट 3x स्क्वायर प्लस 3y स्क्वायर, है ना, जो कि आप लिख सकते हो इसको 3x स्क्वायर प्लस y स्क्वायर, है ना. अच्छा, अब dv क्या है, कौन सा कोऑर्डिनेट सिस्टम का इस्तेमाल किया गया है? यू विल से इट इज कार्टेशियन कोऑर्डिनेट सिस्टम. तो कार्टेशियन कोऑर्डिनेट सिस्टम वॉल्यूम कैसे लिखोगे? dx dy एंड dz, दैट्स इट. सो देयरफॉर व्हाट इज द चार्ज इनक्लोज्ड? चार्ज इनक्लोज्ड विल बी इंटीग्रेशन ऑफ 3 टाइम्स और वॉल्यूम इंटीग्रेशन ऑफ x स्क्वायर प्लस y स्क्वायर इनटू dx dy dz, isn't it? So what will be the limit? Fine. So this is the basically limit. Okay, तो इसको आप ऐसे भी लिख सकते हो 3 इंटीग्रेशन ऑफ एक्स स्क्वायर डी एक्स. सो एक्स कहाँ से कहाँ तक लोगे? नाउ इट इज बेसिकली लेंथ इज गिवन सेंटर्ड एट ओरिजिन, सो प्लस माइनस 0.5, दैट मीन्स इट इज फ्रॉम माइनस 0.5 to 0.5. इंटीग्रेशन ऑफ डी वाई, वाई विल बी फ्रॉम माइनस 0.5 to 0.5. इंटीग्रेशन ऑफ डी जेड फ्रॉम जेड माइनस 0.5 and 0.5 plus. Now integration of dx from x minus 0.5 to 0.5, integration of y dy from y is equal to minus 0.5 to 0.5, and integration of dz from z minus 0.5 to 0.5, isn't it? So when you solve it, you will get the value as 0.5 coulomb. I hope you can solve it easily. So this is the final answer. So this is the question that we have received correctly. So thank you.
Dear students, GATE 2022 Reasoning Aptitude Memory Based Questions in Easy branch. So this time reasoning aptitude moderate and easy, but I got few questions memory based questions, and remain questions data is not in the proper way. So what is in the data proper way, that I am doing in the, so ratio and proportion. P is to Q is to R is to S is equal 5 is to 2 is to 4 is to 3. What they given R is more than S. How much more than 1000? So difference of R, let us take R is equal to 4x, S is equal to 3x, 4x minus 3x, x value 1000. Once x value 1000, they want to find out Q value. Q is equal to 2x. What is the meaning of 2x? 2 into 1000 is equal to 2000. If you are writing directly 2000, nothing wrong. So even though I am writing detail, so P is equal to 5x, Q is equal to 2x.
Color change, white color, yellow. No problem. Black पे write down कीजिए, black पे write down कीजिए. No, black, sir, yellow color. Write down. P is equal to 5x, Q is equal to 2x, and R is equal to 4x. S is equal to 3x. What they given? Difference of R and S 1000. So difference of these two, 4x minus 3x, they given 1000, x value 1000. They are asking about the Q. Q is equal to 2x, 2 into 1000. That is called 2000. Given multiple choice, B is the answer. Same similar problem also you have done in the ratio proportion. These are only direct answers what you have done in the workbook as well as in the classroom. So we are going to second question. I think you all of you understood. You are all of watching. Second question, trapezium. They given length of PQ is equal to 11, length of RS is equal to 6, length of PS is equal to 3, length of QR is equal to 4. H is equal distance between the parallel lines. We have to find out H value. So they given total length is equal to 11. Once you take in 6, this remaining these two both together 11 minus 6 is equal to 5. What they want to find out? Value of H value. So first of all, please go through the diagram. This becomes right angle triangle. This is H, 3. Let us take A. It is also right angle triangle. H4, this will be B. By using these two right angle triangle, we are find out value of H. So this I am writing A, this I am writing B. Let us take, this will be CD. Now this will be 6. Remaining, what is the remaining? B plus A. B plus A is equal 11 minus 6, that will be 5. B plus A is equal 5. Now this right angle triangle H square plus A square is equal to 3 square. Second right angle triangle H square plus B square is equal to 4 square. Using both the right angle triangle, we are finding value of the any one, either B value or A value. Finding any value, we are finding value of H. I think this all will be clear. 11 minus 6 is equal, that will be 5.
B plus A is 5. Now using that right angle triangle, H square plus A square, 3 square is equal to 9. Second right angle triangle, H square plus B square, 4 square 16. Taking these two equations, by subtracting both, B square minus A square, this will be 7. So B plus A into B minus A. What is B plus A? Already you got 5. 5 into B minus A. I am writing directly B plus A into B minus A. B plus you have taken from diagram, that will be 5. B minus A will be 7 dividing by 5. So B minus A will be 7 by 5. Already you got B plus A is equal to 5. Now from this 2B is equal 5 plus 7 dividing by 5. Here B value 16 dividing by 5, because we are getting 2B is equal 32 dividing by 5. Once you got B value 16 dividing by 5 from this diagram, if you want to find out from here, you have to find out A value. You find out any value, either A or B, both are same. So from this, H square is equal 4 square minus B square, 16 dividing by 5, 256 dividing by 25. By simplifying, 400 minus 256, H square 144 dividing by 25. Value of H is equal 12 dividing by 5. Finally, what you can see, H is equal 12 dividing by 5. And multiple choice is not written, but our general aptitude always only MCQ. Suppose if you have any doubt, you also can find out B value, we got it. If you are finding A value, what is A value? 9 dividing by M. If you are finding A value also from this right angle triangle also, H is equal, we are getting same 12 dividing by 5. Either you can find out through B, find out through A. Finding from anywhere, no difference of answers. I think you all will be clear. This is not complicated problem. Student have basic awareness about the trapezium. Third question. This is the inequalities. Inequalities part of the quadratic equations. 2x minus 1 greater than 7. 2x minus 1 less than 9. Then x lies. Of course, they are giving options. X lies, they are giving. Now, from the first inequality, 2x greater than 8, x greater than 4. Second inequality, 2x less than 10, x value less than 5. From both, we can conclude 4 less than x less than 5. So x lies between 4 and 5. Still any doubt verification, let us take between 4 and 5, 4.5. 2 into 4.5, 9. 9 minus 1, 8. 8 greater than 7. 2 into 4.5, 9. 9 minus 1, 8. 8 less than 9. Using multiple choice, okay, but this is very simple thing. We can go for direct answers. So this is the memory based questions. And remain questions, data is not in the proper way. But overall, questions are moderate and easy. I hope you all are watching. Thank you for all.
Yeah, good evening students. I am Srinivas. I teach English. I received two questions. One is a very good question, quite tricky, from an area called critical reasoning. Unfortunately, the data was not sufficient. Question was decent, but we were not able to receive the options of it. Without options, how can I discuss that question? So we have one very basic question based on grammar from an area called conjunctions. We have something called correlative conjunctions, which are used in pairs. We were discussing them in our classes. Either or, neither nor, not only but also, both and, whether or. These are called correlative conjunctions. This question is based on that particular area of grammar. This gentleman is either capable of speaking both the languages, in which case Mr. X speaks. One student sent me can speak. In either case, question is not based on the uses of the verb. It is on proper conjunctions, connective words, right? Whether it is speaks, simple present, or can speak with the help of a modal. In either case, what needs to be used here is the proper conjunction. If he is capable of speaking both the languages, you can tell it in two ways. Mr. X speaks both Japanese and Chinese. Do you have that option, both and? No, don't worry about it. So you also have another possibility. Mr. X speaks not only Japanese but also Chinese. Do we have that? No. We have an option called also but, which is incomplete, right? It is incomplete, my dear friends. How is it supposed to be? It is supposed to be like this. Mr. X speaks not only Japanese but also Chinese. We don't have that, so remove this option. And then neither, either or, either is given, that nor is given, which is a bad combination. Same with this. If you use either or, he is capable of speaking one language between these two. Okay? If you use neither nor, that means maybe he is good at Hindi, he is good at Telugu, he is good at Spanish or French. So he does not speak both the languages. So it should be neither nor, but he gave neither or, which is again a bad combination. So what do we have here? Option A, he speaks neither Japanese nor Chinese. That means maybe he speaks Spanish, French or Hindi, right? That's it. Basic question, fundamental grammar, right? Fine, my dear friends, best of luck.
Good evening students, I am Srikar Gupta, Faculty of Mathematics. So here I have come with the solutions of engineering mathematics. So hope you are waiting for these solutions for the electronics 2022 GATE examination. Okay, right. The questions are a little bit difficult side. So let's see what are the questions, and those who attended the classroom, those who attended the class, so definitely they can do all these questions very comfortably. So with the basics which we provided and with the concepts which is provided. Okay. So now here the thing is that first question, you can see the first question, the simple closed conduit, it's a complex integration part, right? And he has given the integral value as minus I pi a. So then what is this a value? So let us find out the exact integral value and equate with the minus pi a, and you will be getting it, right?
So as this is f of z, so from this it is very clear the poles are given by z square minus 1 is equal to 0, which implies z is equal to plus or minus 1, right. So these are simple poles, right, these are simple poles, right. But you can see that from the given contour here, it is minus 1 comma 0 is lies inside and 1 comma 0 lies outside here. So therefore, so what we have to do is that here the integration c f of z dz is given by 2 pi I into the residue at minus 1, the residue at minus 1, it is the minus 1 point which lies inside. So therefore 2 pi I into here, what is the residue at minus 1 for the function? So from this here z plus 1 gets cancelled, only z minus 1 will be left. So it is going to be 2 to the power of minus 1 minus 1 minus 1. So this is the residue here. So this is going to be here minus this 2 gets cancelled and pi I 1 by 2 you get it, right. So therefore which is equal to minus I pi a. So therefore a is equal to here exactly 1 by 2 you are getting it, a is equal to 1 by 2 you are getting it, okay. So this is 2 gets cancelled here and this is pi I and this is 1 by 2, it is minus. So it is minus pi I a is given. So equating with that you are getting 1 by 2 here, right. So the answer for this question a is 1 by 2. So move on to the next question without any wasting the time. So going on to this partial differentiation, last year also we have got the partial differentiation question here. So this is the question we have got. Now clearly you see that this is the function, exponential function, right. So अगर उसको differentiate करते हैं तो x, y, so the function will be repeated, right or not. The same thing I am going to do here. So I am differentiating this f for 2 times with respect to x. So with respect to x means as an internal derivative this this xi will come for 2 times here. So this will give you a into, okay, right, into f, right. So you are getting this, then plus b into with respect to y. So this neta will be coming twice. So therefore, so it is a neta square into f, because same exponential function f will be repeated and this is equal to f, right. So equating on both sides, so you are getting that a square plus b neta square is equal to 1 here, neta square is equal to 1. Now as there are given options, you substitute the options into this, which option will satisfy this one. Suppose if you put option b into this here, so a is equal to 1 by root a, so a gets cancels and you are getting 1 and neta is equal to 0. So option b is perfectly satisfying here. So therefore option b is the right answer for this, right. Right. So moving on to this question here, the next question we will see that consider the two-dimensional vector field. Vector field is xi plus yj. It's a very, very simple question, my dear. Those who attended the classroom, so classroom the course, so definitely they can do it in just 1 minute. 1 minute भी नहीं लगता है, just seconds में answer कर सकते हैं. ये क्या है? f bar dot dr bar. So this is equal to what? Exactly what is this is equal to? So this will give you closed integral c, because it is a closed contour, right? So it is x dx plus y dy. Yes, it is very simple, my dear. X dx plus y dy is a total derivative. So if the integral function is a total derivative over the closed contour, directly it is 0, because this is a conservative one. This is a conservative, the vector is going to be conservative, so that is why this integral becomes 0 for the closed contour directly. So the answer for this one is 0. I think majority of the students have done this question here, right? Yes. Next question here, f of x is equal to 8 ln x minus x square plus 3 attains its minimum over the interval. See, always this concept will come. Definitely it's a most probability question, so that is why it is occurred. So we have to see that whenever the interval a comma b is given, we have to check f of a. See, suppose this is a comma b, right? So you have to find out f of a, you have to find out f of b, and if at all any local minima occurs, so that also you have to take into the consideration. So first let us see that find the stationary points. the stationary points are given by f dash of x is equal to 8 by x minus 2x is equal to 0 here, and from this you are getting x is equal to plus or minus 2 here. So, but here from this I can say x is equal to 2, minus 2 lies outside of this given interval, only minus 2 lies, sorry, plus 2 only lies interval a comma b, right. So, let us check what is f double dash of x, okay, minus 2. So, f double dash of here if you put 2 here, so you are getting negative. So, that means, see, second derivative is negative at the stationary point, means it is very clear that it is f is maximum here, right. F is maximum at 2 here. So, there is no local minima, right. So, I will write like this. So, this implies that no local minima, right. So, hence the minimum of f of x in the interval 1 comma e is given by, so minimum of f of 1 comma f of e here, right. So, at f of 1 we will have the maximum value, minimum value. So, that is going to be ln 1 is 0. So, it is 3 minus 1. So, 3 minus 1 is going to be 2 here, right. So, this is the minimum, right, and this is going to be 2, and for this one I can say simply like this, this is 2, right, this is minimum of 2 comma, this is something greater than 2. So, something greater than 2 means, so minimum value is going to be taken as 2 here. So, this 2 is occurring at x equal to 1. So, therefore, our answer is here, this A is the correct answer. A is the correct answer for this. So, A is equal to 1. At 1 the function will have the minimum value, right. And this one another. So, double integral question is compulsory question, right. So, from this year we have to do this double integral of this, right. So, for this region we all know that out of the two variables we need to fix one of the variable as constant limits, and we have to take the other variables as the variable limits, correct or not. तो हम लोग क्या करेंगे, तो ये है 4 है. So, can I say that x varies from 0 to 4 here? So, I can say x varies from 0 to 4 and y varies from where to where. So, y varies vertically always, that we always we know that the y varies vertically over the region. So, y is equal to what? See, this is the line which is y is equal to minus x, and this is the line which is y is equal to x here, because it passes through origin, right. So, therefore, minus x to x. So, therefore, this integral is going to be taken as 0 to 4 minus x to x, and this one 3x square, right. So, 3x square plus 3y square into dy and then dx. So, this one is 0 to 4, and this integration with respect to y, it is 3x square y, and this is going to be y cube, right, y cube, and the limits you put it here. So, limits are minus x to x and dx, right, and then you have to put this one. So, then you are getting ultimately, so it is of something integral 0 to 4, and this is a 3x cube and x cube. So, it is 4x cube, then minus of, if you put minus x here, so this is minus 3x cube and minus x cube. So, minus 4x cube. So, it will be minus 4x cube dx, right or not. So, now if I take it this integration here, I am going to get 0 to 4. So, this is about 8x cube, right. So, 8x cube integration क्या होता है directly, 8x cube integration is going to be, so 2x to the power of 4 from 0 to 4. So, 2 into 4 to the power of 4. So, this is going to be 512 here, 512. So, this is the answer for this question. This is the answer for this question here, okay, right. So, moving on to the next question, that is a linear algebra. linear algebra question, right? See, if you are observing this question directly, it's a very simple question. See, from this equation, you can see this very clearly that, see, this is equal to, we all know that Ax is equal to b or not, Ax is equal to b, right? So if you write this Ax is equal to b with this, so then I am getting x minus root 2 y, okay, plus 3z is equal to 1 I am getting. Other one is minus x plus root 2 y and minus 3z. So according to the first equation, so this should be minus 1, but actually it is minus 1, but this is equal to given as 3, which is not equal to minus 1. So therefore, so these equations are inconsistent. Inconsistent means no solution here. So according to the memory based data, so this was the conclusion this was the question I got. So maybe the question may have a little more this thing, but as of now, based on the memory, so this is what the question, and from this question I can give you this much clarity of this what is going to be the answer for this question. So it's an inconsistent here, right? Now next question is see, the sequence and series is added in this year from GATE 2021 onwards. So this question is asked for electronic students. I told you in the classroom also this question will come from sequence and series, right? So this is what. Now let's look at this. So it is not a MCQ, it is a MSQ question according to me, because see, this question is given something like this, right? Converges for what value of C and D. So there are more options are there here. Now I will use each option here. I will use each option here, right? So if I take option A here, in option A, C is equal to 2 and D is equal to 1. So then this series is going to be what? Please observe this. This series is equal to. So C is equal to 2, it is 2 to the power of n, and this is n. So n by 2 to the power of n here. So this is an infinite series you got. I told you in the class, so whenever you have the power n, whenever you have this ratio terms of n, so we can go for ratio test here. So therefore what I do is, I will apply ratio test here. I will apply ratio test. So that is limit n tends to infinity un plus 1 by un here, right? So limit n tends to infinity, right? N tends to infinity here. Un plus 1 is what? N plus 1 by 2 to the power of n plus 1 divided by un. So that means it is going to be 2 to the power of n by n here. Are you getting my point? Yes. Now let us look at this each option here. So it may take some little time in this. So anyway, so these and these will get cancelled for 1 as n tends to infinity, right? And this 2 to the power of n, this 2 to the power of n gets cancelled, and you are going to get 1 by 2 as n tends to infinity. If you apply limit, you will understand. N common n gets cancelled. So 1 plus 1 by n is going to be 1 here. So therefore 2 power n gets cancelled here, right? And you will have a 1 by 2. So 1 by 2 is a less than 1. So less than 1 means, so by ratio test it is convergent. Sigma un is convergent. So therefore option A is correct, right? Option A is correct here. But if you go with the other option like option B you take 1 and minus 1. So for 1 and minus 1, summation C un is equal to what? Sorry, C is equal to 1 means, so it is 1 to the power of n, and n is D is equal to minus 1. So it is going to be simply 1 by n. See, 1 by n is a divergent series by p test, right? So it is directly, you can say, the divergent by p test. By p test, because I have told you very clearly the condition is that, so p greater than, if 1 by n to the power of p is given, suppose if p is greater than 1, it is convergent, less than or equal to 1, divergent, but here the p is equal to 1 you got, so therefore it is divergent, right? So option B is divergent, right? Now option C, 0.5 and 10. So simply I will tell you 0.5 and 10 means, so here it is going to be C is equal to 0.5, so it is 1 by 2 to the power of n, and this is going to be n to the power of 10 here. So for n to the power of 10 and 1 by see what is going to be happen. Let me write this. Option C, summation un is equal to summation, and this is n to the power of 10 by 1 by 2 to the power of n here, right? This is what you have. Again the ratio test we apply. So limit n tends to infinity. So un plus 1 by un is giving you what? See, this is n plus 1 to the power of 10 by 1 by 2 to the power of n plus 1, and this is going to be 1 by 2 to the power of n by n power 10 here. So these and these will get cancelled for 1 for as n tends to infinity, and this 1 by 2 power n, 1 by 2 power n gets cancelled. See, don't ask me that, so how this gets cancelled 1 here. See, if you apply limit n tends to infinity on this, you will be getting 1 here. So you see that. So I may not say that it is exactly cancelling, but you will get 1 here. Okay, so these 2 will give you 1, and this is going to be 2, so it is greater than 1. So it is very clear it is a divergent by ratio test, because by ratio test this un plus 1 by un is less than 1 means convergent, greater than 1 means divergent. So that is why, so option C is divergent. So now I will go with option D. So option D is what? 1 comma minus 2. So 1 comma minus 2. So I will just do this one here on this one only. Option D, if you take, C is equal to 1. So 1 to the power of n is 1, right? Because n is an integer. So minus 2. So it is n to the power of minus 2 by 1 to the power of n is summation 1 by n square. So here the p value is 2, which is greater than 1. So therefore here is convergent by p test. Convergent by p test. So therefore, so option A and D both are correct. C and D are wrong because they are for divergent. So for option A and D, this is going to be convergent here. Okay. Options are not right. So maybe because the thing is that we have taken based on the memory, right? So therefore they may be little bit varied, but the concept which I mentioned here, it is correct. So according to that you can answer that, right? Okay, right. Yes, yes, it may vary. Okay, don't worry, right? So this question is there. See, this based on the roots. So from the control system part you can understand because it deals with the roots concept here. So P of S is given as s power 4 5s cube 5s square plus c. See, I can tell you this way. The question here I can say this. So if you are taking this s square is equal to x here. So let s square is equal to x here, right? So then I can write this f of x is going to be here. So this is going to be x square plus 5x plus 4 plus k plus 4 plus k here, right? So this is a quadratic equation we are getting. So therefore, so if I write that s square x is equal to, if I write the roots, s square is equal to minus 5 plus or minus under root b square minus 4ac. So 4ac here divided by some 2a. So that means 2 here. Dear students, see, as the roots must be imaginary here, right? As the roots must be imaginary means, so definitely this part must be negative, right or not? If this part must be negative here. So therefore I can say like this, not this part, wait a minute, not this part beta. So this s square value to be negative, correct or not? This s square value to be negative. If s square value to be negative, so then in that case there is no doubt that, see, under root of 25 minus 4, so it is taken as 16, that is 9 minus 4k, right? So 9 minus 4k must be greater than 0 or greater than or equal to 0 you can take. So because square root is always positive na, so therefore, so this must be positive, this square root must be always positive, right? So this is positive because square root value is always positive here, so positive here, right? And what about this one inside? So inside, so this one can be here, must be less than 5, must be less than 5. So therefore it is must be less than 5 here. So from this you are getting that k is greater than minus 4, you are getting from this, and other one is that k is, okay, less than 9 by 4 you are getting it, right? So from this you can see that 9 minus 4k should be greater than or equal to 0. So k is greater than or equal to 9 by 4 here, right. So minus 9 by 4 here. So k greater than minus 9 by 4. Wait a minute. So it is going to be here k less than so from this you are getting this condition, right. So k must be greater than minus 4 and k must be less than 9 by 4. So this is what you are going to get in this this thing according to the roots conditions and all. So with this I am concluding the mathematics part. So I hope you have done all these questions very easily, right, and with this I am concluding the session also, right. Thanks for watching. Thank you.